committee member of Telangana State Center PR Division Board, and today's webinar moderator, Dr. G. Chandramohan Reddy, FIE, former Honorary Secretary, the Institution of Engineering, Telangana State Center, and Principal of MGIT, and presently Professor and Head of the Mechanical Engineering, CPIT, Hyderabad. And the respected today's speakers, Dr. Rakesh L. Srivastavaji, FIE, Council Member, Institution of Engineers, India, Engineer Asim Inamda, IVEX Lifestyle Vertical Expert, Indorama Ventures India Limited, India, Engineer Hanumantrao, Additional General Manager, Usha International Limited, past Presidents, past Vice Presidents, Council Members of Institution of Engineers, India, past Chairman, past Honorary Secretaries, members of Telangana State Center Committee, and corporate members of Institution of Engineers, India, distinguished guests, representatives of media, ladies and gentlemen. Today, I feel it is a great privilege and honor to be amidst this August virtual gathering and extend a warm and hearty welcome to the Chief Guest, Vice President, and other Chairman of CATE, and all of you to this IEA technical webinar on productivity improvement in SMEs with implementation of lean manufacturing tools. Today, I am very happy to be associated with this memorable event. The Institution of Engineers India, founded in 1920 and incorporated by Royal Charter in 1935, and is a multidisciplinary body of engineers having 8 lakh membership with 15 engineering divisions and interdisciplinary panels, and with 125 state and local centers across the state capitals and towns of industrial and academic importance in the country, and 7 fora and 1 organ for focused attention in specified areas of activities. The IEI, leveraging its unique legacy as a qualifying body and society, engaged in spreading quality professional technical education since 1920, and it working brilliantly for national development. The Institution of Engineers India boasts various membership categories such as fellow member, associate member, senior technician, technician member, student member, and institutional member. The institution prides in itself is being the forerunner of Bureau of Indian Standards, India National Academy of Engineers. Interestingly, the Institution of Engineers accredited IIT Kharagpur, the first IIT in the country, in the year 1956 at the behest of Government of India. And the IEI vision is to enable practice of ethical ethos and pursuit of professional excellence of engineering fraternity to serve the humanity through inclusive growth. And I would like to say a few words about Telangana State Center, and we are proud to announce that the Telangana State Center of the Institution of Engineers is the only and first center out of 125 centers in the country was awarded ISO certification 9001-215 in the month of April in the history of 102 years of Institution of Engineers. And it is one of the most active centers of the Institution of Engineers India, which engage successfully in translating the objectives, vision, and mission of the Institution of Engineers India into practice. Within its formation of 2 years, TSC has bagged Best State Center Award twice and has been playing very important role in dissemination of information on engineering and contemporary technology, bringing industry, academia, experts, and professionals together on the same platform by regularly organizing international conference, national conferences, conventions, all India seminars and workshops and roundtable conferences and panel discussion throughout the year, almost one program or an event every 3rd or 4th day. I would like to small brief on, on the today's event. And the SMEs are the lifeline of country's economy. Their survival and growth is critical to national development, and they are required to perform with modest resources at their disposal while facing stiff competition in the marketplace. Most organizations today are going through a stage where there is a necessity to respond to the rapidly changing customer needs. Industries are trying to implement new and efficient technologies in their manufacturing operations. Some of the established tools are applied, and its realization has been growing among the industries, particularly in manufacturing sector. And quality and productivity improvement initiatives are implemented using various tools and techniques in the manufacturing area. To sustain their place in the market, many organizations have started following the lean manufacturing concept, and lean tools allow the organization to focus upon elimination of waste, reducing current lead time, stock levels, and cycle times to find out the ratio of value-added process to the total lead time of the product life. Adoption of these tools and methodologies advocated by lean manufacturing with the correct understanding can provide answers to several challenges faced by the industry. The objective of this webinar is to understand the concept of lean manufacturing, its philosophy, various tools and techniques, lean implementation, benefits and barriers towards lean implementation. The discussion shall essentially bring to focus the role that can be effectively played by lean manufacturing tools like 5S, Ryzen, Muda, Coca UK, VSM, and Six Sigma and ETC for improvement in their work. On behalf of the Telangana State Center of the Institution of Engineers India and on my own behalf, I once again extend a hearty welcome to today's respected chief guest, Dr. Jaitit R. Joshi, Program Leader, Kusha, DRDO, Hyderabad, our Vice President of IEI, Engineer V.B. Singhvi, FIE, and Chairman, Production Engineering Division, Dr. S. Satyanarayana, and Chairman for Committee for Advancement and Technology and Engineering, the Institution of Engineers India, Dr. G. Ranganathji, FIE, and all of you to this important event. And thank you one and all. And may I request Dr. Satyanarayana Garu, to, Chairman of Production Engineering Division Board, to kindly address this virtual gathering. And over to Satyanarayana Garu.
Unmute your system, Satyanarayana Garu.
Yeah, okay. So I'm sorry. Chief guest of today's webinar, Dr. Jaitit R. Joshi, is the program director now. He's not a program leader, and he is now till recently has been taking care of LRSAM. You know that LRSAM is Israel project, and now he has taken over the program director, not the program leader. So this is to be corrected. And one more thing I just want to share, our moderator, Dr. Chandramohan Reddy. Earlier, he was the principal of MGIT, Mahatma Gandhi Institute of Technology, and a professor in Chaitanya Bharati Institute of Technology. Yesterday, and he served as, for 6 years, he served as a principal of MGIT. And due to various reasons, yesterday he has been again requested to take over as the principal. And now he is the principal of MGIT since yesterday onwards. I congratulate him for taking over again as the principal of MGIT, the most, sought after college in Hyderabad. Now,
Thank you very much.
Now coming to this, all the dignitaries for participating. Good afternoon to all of you. Our chairman, Brahma Reddy Garu, has already narrated about the webinar. But at the outset, let me compliment our Telangana State Center Chairman, Sri Brahma Reddy Garu, and Executive Council Member, Saraswatamma.
Thank you, madam.
Dr. K. Saraswatamma, he is the professor, Mechanical Engineering Department, taking care of the production engineering. And other council, committee members who have selected this very, very important topic. this topic is very apt at this present scenario because today MSME sector is facing various problems, more particularly after the COVID. COVID-19 has crippled the MSME sector and they're just crawling. They are not able to move faster. So in such a scenario, helping any help that we extend to them is really great. And being a professional institute, I always tell our people, let us take a topic which is useful for the society, and society has to directly get benefit out of this. That is how they have selected this topic. And productivity improvement.
चलिए
Sir, mute చేయండి. Somebody has to mute. Sir, somebody has to mute this.
Chandramohan Reddy garu has to mute.
You cannot believe.
Dr. Chandramohan Reddy.
So happy.
Sir, Chandramohan Reddy, you have to mute. You are talking to your staff members.
Yeah, he is muted now. Please.
As far as the MSME, so this is very, very relevant topic and most apt for this, small scale industries, and definitely society and the small scale industry will get benefit out of this today's webinar. And coming to this, MSME sector, India is having the largest MSME sector after China. We have about, almost 6.33 crore MSME sector in India, out of which major MSME sector is in UP, Uttar Pradesh. Next comes to Maharashtra, and third is Tamil Nadu. This is way out of 6.33 crore MSMEs, 6.3 are micro industries. You can just understand micro. They are situated in rural India and various other places. They are doing their business or maybe industrial activities which is inherited from their forefathers, and like a family business they are doing it. So such kind of people, this kind of latest technologies and tools are very much useful. When you come to the small scale industry, there are about 3.31 lakh small scale industries, and about 5,000 are medium enterprises. About 2,000 are the large industries. So MSME sector is contributing a lot, particularly in the manufacturing sector and also export sector. And any help you render to the MSME sector is really great. And I really compliment our Telangana State Center for selecting a very, very useful and apt topic for the today's society, and more particularly for the MSME sector. And all of you are aware, what types of problems are MSME sector facing today. They are, particularly poor capacity utilization because they are not qualified. Most of the people are not qualified. They have the capacity, but they don't know how to utilize the capacity. And management, they lack the management skills because they are all, they come from the family background, for their uneducated background, and who are artisans, most particularly in this area. And they are, they need some sort of, this kind of tools and management techniques to be, imparted to them, so that, they will also understand what is the management and what type of, management tactics they have to use in their industry. And one more thing is, inadequate finance, raw material shortage. Today, raw material shortage, steel cost has gone up like anything. Steel cost, earlier it was about 40 rupees per kg. Today it is about almost 100 rupees per kg. This down, all the cost of all the raw materials have gone up. In such a scenario, it is really, very, very important to take up this very important topic and, disseminate this knowledge to the small scale sector. And coming to the productivity, all of us know, productivity is the ratio between the output to the input. And earlier, when I was working in a company called, Sahani Paris Rowan Limited, I was a senior methods engineer. I used to, stand with a stopwatch near the operator and do that, time and motion study. All the techniques have totally, become obsolete and outdated. Today, there are, missions, CNC missions, technology upgradation, various things have taken place. In such a scenario, if you do not properly use the technology available and the investment that is made on the technology, and it will all become a waste. So the productivity, how to improve the productivity by using the lean manufacturing tools is very, very important. And when you talk of the operational efficiency, one is the productivity, other is operational efficiency. When you talk of the operational efficiency, these lean manufacturing tools will really help the people to improve their operational efficiency. And how to measure the operational efficiency? There are all the various things that are to be taught to, or that are to be disseminated to the small scale industry. And today's topic, I feel, this is a very, very important topic and going to be delivered by expert people like our Dr. Rakesh Srivatswasa, who is a quality guru. He is implementing various quality management systems in various industries all over the India. And one Mr. Dr. Asim Inamdar, he was a professor in production engineering and is a QMS expert in working in one engineering college. And one Mr. Hanumant Rao, he is also very, very qualified and expert in quality management systems, because he is a faculty for the Quality Circle Forum of India. We have an organization called Quality Circle Forum of India, where they deal with 5S, quality circles, and all other quality systems. And he is a faculty there, he is a governing council member. And he is also going to deliver. With all these things now, probably we will get real benefit, and the smaller scale industries will be really benefited out of this talk. With these few words, I thank all the members, particularly our VB Singh Sahab, who has joined all the way from Lucknow, in spite of his busy schedule, and he is already organizing one seminar there. In between, he has come here to join us, and our Ranganath Sahab, and our chief today's chief guest, Dr. Jaityar, he is talking from Tirupati. He has gone to have a darshan of Lord Venkateswara Swami. From there, from his hotel, he just joining us. This is the thing what is happening now, and I thank all of you for taking time and coming to this and delivering the lecture. Thank you very much, sir.
Thank you, sir. Dr. Satyanarayan Garu. So, sir, I am still seeing program leader on beside sir's name. In fact, I was confused.
No issues, absolutely no problem. It doesn't
sorry,
make
sir.
any difference.
I'm
I am
sorry for
Joshi, that's it, sufficient.
I'm sorry for and now may I request Dr. G. Ranganath Garu, the chairman of CATE, Institution of Engineers, kindly to address the topic. Over to Ranganath, sir.
Thank you, Chairman. Telangana State Center, my dear friend Brahma Reddy Garu. The achievement of today's function, sitting Vice President, good friend of me, through VB Singh ji, eminent engineer, Dr. R. Srivastav ji, Satyanarayana, who is the chairman of production PRDB, and as well as is representing as a council from PRDB. The most important personalities for this program is speakers. Dr. J.R. Joshi sir, who is coming as a scientist from the DRDO. Madam Saraswatamma, as an academician and representing the production sites. Professor Hanumant Rao is another speaker. Professor Asim Inamdar, who is representing all these things here. The moderator and who is honorary secretary of Telangana State Center, Dr. Chandramohan ji, who is again assumed as a principal of another engineering college. I am so happy to see him here. And all other committee members of Telangana State Center and dear most participants. I am so happy to extend my evening greetings to all of you. In fact, I am so happy to share here, and Brahma Reddy was keep on telling so many things about Telangana State Center. In addition to that, I am very happy to endorse. From past 1 year, I am observing Telangana State Center and West Bengal State Center are the front runners in conducting good number of programs and particularly in webinar. Generally, even for seminars, we used to invite 1 or 2 speakers. But here they are inviting speakers even 4 to 5 members. And for all your information, Satyanarayana is again speaker of the same division. He is not only chairman, he is equivalent to speaker. The data how he is sharing with all of you regarding MSME, small scale industries, real problems what they are facing. So all these things we are going to come across. Certainly Satyanarayana is again being a chairman of PRDB, is another speaker. with my experience of past about 1 year as a CATE chairman, maybe about 9 months in CATE chairman, I'm so happy this Corona teaches a beautiful lesson of webinars rather than seminars. The advantages of webinars you can understand today. Or another important speaker, a scientist from DRDO, is sitting in Tirupati for Lord Venkateswara Darshan. For whom he is going to join us and he is going to spend his valuable time. Madam Saraswati Amma is sitting in a car and she is going to spend her valuable time. See, the world has become so small because of webinars. Now, I want to bring some changes in webinars. In coming CATE meeting, I am going to give proposal. All council members like Srivatavji, VB Singh, Satnaraji and Brahma should understand. I am going to remove all the formalities for approvals. The board chairman and host center chairman decides enough. No need to come to headquarters for permission. I am going to bring the changes. One change. Second change, what I want to bring, we want to minimize as much as possible time for formalities. Brahma has given beautiful formality on Vande Mataram. That's enough. Remaining all, we should spend time by listening to speakers. When there are coming speakers from different domains, spending a valuable time, we should utilize the services, utilize the technological input from them, and participants should feel double happy. This is the second change I want to bring. Why I want thinking on this particular angle, when Marine Division has conducted some progress of webinar, Commander Bandarkarji, he brought some speakers from international repute from outside the country. On that day, they were feeling little uncomfortable because less of time. Time was not available enough to them. So I felt as a chairman of CATE, and the president has made me to become this responsible executive. We want to bring some changes in the organization to see effective execution in the future too. So these changes we are going to bring. This I want to share with all of you. Now coming to today's topic, hats off to the Telangana State Chairman and committee members, those who are representing the production division, the chairman of BRDB, a real topic and order of the day topic. Certainly is going to have a lot of inputs to the participants. You can see more than 40 participants are there now. More than 40 participants there in line to listen the speakers. By congratulating Telangana State Center, Chairman and Secretary and all of the committee members, congratulating our PRDB Chairman, and thanking all our speakers like Joshi Sir, Madam Saraswati Amma, Anamant Raoji, Asimi Manda, by thanking all four of you from IOI for your valuable time spending as the speakers, and thanking our VB Singh and Srivatavji joining this program all the way along with me. And let me congratulate and let me thank all of you and let me wish program is going to be a good success. Thank you all.
Thank you, sir, Dr. Ranganath sir, for giving us a lot of this thing. In fact, I wanted to request you, recently you applied for one electronics program, IoT Enlightened, and we were denied, saying that change the date, because the dates cannot be changed because we had had a tie-up with some college for that webinar. And anyway, fortunately, it went up to now October 1st instead of 10th September. So the changes you are proposing is supported now itself by me and also in council. And this is a must, because one should not have control from headquarters. Some assistant director is saying you change this date, you change this date. It is the, as you said, it's the host state center, which is comfortable along with the division board chairman. It should be done. Thank you, sir. Thank you for your excellent address. And now it's a time for me to request our Vice President, sir, Engineer VP Singh ji, to address this thing. Before that, I would like to say a few words. He is a Bachelor of Law and postgraduate diploma in Public Administration from Lucknow University. He joined UP State Electricity Board, and also he served in different capacities for 38 years, and he worked on various assignments covering planning and designing and thermal other things. And he is associated with the Institution of Engineers long, and now today is vice president, rise to the level of vice president of the Institution of Engineers, a prestigious world professional body. So may I request now Engineer VB Singh Saab to kindly address the gathering, sir. Well, over to VB Singh sir.
Thank you, Dr. Reddy. Thank you so much for my introduction. Chief guest of the session, Dr. Jaitir R. Joshi, Program Leader, Kusha, DRDO, Hyderabad. Eminent panelists of the session, Professor Dr. Rakesh Srivastav, Council Member, and my friend, Mr. Asim Inamdar, IVEX Lifestyle Vertical Experts in Indorama Venture Limited, and Mr. Hanumant Rao, Additional General Manager, Usha International Limited, moderator of the webinar, Dr. G. Chandra Mohan Reddy, former Honorary Secretary, IIAP State Center, former Principal, Mahatma Gandhi Institute of Technology, and Professor, Department of Mechanical Engineering, CBIT, Hyderabad. And most respected Dr. T.M. Gunaraja, former President of the Institution of Engineers, most young and dynamic CATE Chairman, Dr. G. Rangnath, my friend, and Dr. Shriram Satyanarayana, Chairman, Production Engineering Division Board, Mr. B. Brahma Reddy, Chairman, Telangana State Center, Dr. G. Venkat Subbiah, Honorary Secretary, Telangana State Center, and all attendees who are always in pursuit of knowledge. A very good afternoon to all of you. Friends, I consider it a great opportunity for all of us to be a part of this technical webinar on productivity improvement in SMEs with implementation of lean manufacturing tools being organized today by Telangana State Center under the aegis of Production Engineering Division. So first of all, I congratulate and compliment Telangana State Center, which has organized number of technical activities very regularly, and also congratulate and compliment Dr. Shriram Satyanarayana Saab, Chairman of the Production Engineering Division, who managed a number of activities under Production Engineering Division, though it is comparatively a smaller division. So friends, the Institution of Engineers India always put sincere effort to keep its members informed and abreast about the latest engineering and technological developments occurring in national and international arena through organizing technical events on regular basis involving eminent professional practitioners. Over its last 100 years of existence, the institution has provided valuable suggestions and policy inputs to the policy makers, contributing to the national growth. For the last 2 years, as you know, with the strictly imposed restrictions due to pandemic, technical webinars were conducted by the institution on contemporary topics regularly, which provide a virtual knowledge sharing platform for our members and the professionals attached to the specific domain. The Institution of Engineers has conducted approximately 150 technical webinars with comprehensive coverage of various engineering topics, which have witnessed enthusiastic participation from wide range of professionals during this period. As the world has moved closer to the global economy, competition between manufacturing companies has also become global. This increasingly competitive environment has led to the intense study of companies that are at the top in terms of competitive position. The concepts of lean thinking and lean manufacturing was developed for maximizing the resource utilization through minimization of waste. More precisely, lean manufacturing methodology focused on eliminating wasteful practices for better productivity and efficiency while promoting customer value. Lean principle enables quicker responses to changing customer demands, faster production, and increased quality with subsequent cost effectiveness. Small and medium-sized companies embrace lean methodologies to increase customer satisfaction and competitiveness in the global marketplace. Frequently, small businesses need an effective production system that can address low volume with a high mix of products. Lean allows manufacturers to identify waste, increase flexibility to ensure delivery of the right product at the right cost at the right time. Lean methodology provides the most effective platform for rapid and sustainable future growth of the business. Lean tools provide the framework to solve the problems, measure performance, analyze and optimize work processes while helping to manage people and change. Lean manufacturing tools are intended to help drive out waste, simplify process control measures, result efficient material and process flow, improve quality control, leads to the optimal utilization of resources. To this end, the webinar is being organized involving renowned experts from industry and academia to discuss and highlight the pertinent issues of improvement of productivity through lean principle. We are interested to hear about different lean manufacturing tools, including JIT, Kanban, value streams mapping, productivity improvement tools through lean concept, and so on. The deliberations on these issues are expected to provide us more insights and leave us enriched. I hope that the discussions during this webinar will encompass all facets of the subject holistically, involving all stakeholders. We are eager to hear from experts on this emerging topic, and I hope everybody will get enlightened by their presentations. I wish this seminar all success, and thank you all.
Thank you, sir, VP Singh Saab, for your wonderful inspirational speech and address to the gathering. Thank you, sir. Now, may I request Professor Dr. K. Joshi Saab.
Sir, good afternoon, sir. Thank you, sir. Sir, am I audible, sir?
Yeah.
Yeah, you're audible.
You're audible.
Sir, good afternoon to one and all. And it's a privilege to introduce the chief guest of today's webinar, that is on productivity improvement in SMEs with implementation of lean manufacturing. Of today's guest, Dr. Jayatith R. Joshi is a mechanical engineering graduate from Usmania University, a management postgraduate from Pune University, and obtained his PhD from NIT Warangal. He is a program director of LRSAM at DRDL, Hyderabad. He is a governing council member of ARCA, that is Department of Science and Technology, distinguished visiting professor, INAE AICTE chairman, Indian Institute of Welding, and vice president, Indian Society for Non-Destructive Testing. His specialization including welding and non-destructive testing of aerospace materials, weapon system development, cutting-edge technologies of missile engineering and project management. His expertise has uniquely harnessed the industries and educational institute, leading to the development of complex defense technologies since last 31 years. He has made significant contributions in the field of non-destructive testing and has tangibly helped to promote the LDT culture across the country. He is a fellow of Telangana Academy of Sciences, Institute of Engineers India, Indian Society for Non-Destructive Testing, Indian Society of Mechanical Engineers, Indian Institute for Production Engineers, Indian Institution for Plant Engineers, member Hyderabad Management Association. For his outstanding contributions in missile engineering, he has been bestowed with many awards. Notable among them are Technology Group Award in 2008 and Distinguished NDTN of the Decade by ISNT in 2012, Laboratory Scientist of the Year in 2013, National Technology Day Oration Award by DRDO in 2016, DRDO Performance Excellence Award in 2016, IIM SAIL Gold Medal in 2018 by IIM, Eminent Scientist 2019 by Lions Club International, Scientist of the Year in 2019 by DRDO, Bharat Ratna Sir Mokshagundam Visvesvaraya Award by Institute of Engineers in 2020, Technology Group Award in 2020 from DRDL, Sir C.V. Raman Memorial Lecture Award in 2021 by IWWA, the Manager of the Year Award in 2022 by HMA Hyderabad. So thank you, sir. Thank you for giving the opportunity to introduce our speaker of today's webinar.
Thank you, madam. Thank you. May I request today's respected chief guest, Dr. Jayatith R. Joshi Garu, Program Director, sir, kindly to address the gathering and do your valuable speech.
Namaskar. Am I audible?
Yes, sir, you are audible.
Chairman Sri Brahmanand Reddy Garu, Dr. S. Satyanarayana ji, Dr. Ranganath ji, panelists for the technical webinar and delegates. A warm welcome to you all on this platform of Institute of Engineers, which is doing a yeoman service in dissipating engineering knowledge by bringing in large number of highly knowledgeable experts in the field to develop the skill set of young engineers and hone the knowledge of working engineers like us. Today's topic of productivity improvement in SMEs with implementation of lean manufacturing tool is apt in the present industrial environment. The SMEs, as told by Dr. Satyanarayana, plays a very important role in economic growth of rapidly developing countries like India, where, as told earlier, we have a network of about 6.3 crores industries, which produce more than 7,500 products. They contribute around 29% to the national GDP. Today, about 111 million people are employed in SMEs, and it has a vast potential to create another 10 more million in the next 2-3 years. These statistics clearly indicate the productivity improvement of SMEs can significantly boost the total productivity of the country as measured in terms of GDP and purchase power parity. When you look at the last 2 decades, which has witnessed awareness in the area of quality and product improvements initiatives in the Indian SMEs to improve the productivity using various tools and techniques like lean manufacturing, total quality management, Six Sigma, ISO certification, and AS certification for aerospace industries and defense industries who are into that one. And a lot of training, and as told earlier, training is required. There are few societies, they are giving a specific training like Indian Society for Non-Destructive Testing, which gives a specific training to the SMEs by way of level 1, level 2 and level 3. Whereas Indian Institute of Welding gives specific training for the welders and the engineers. Like that, we should evolve training mechanisms in the productivity, destructive testing, lean manufacturing tool. Those things also we should evolve a mechanism. As this panelist will be discussing on that one, we should have a mechanism to bring in these things and force the SMEs to join these things at a very, very nominal fees so that they can learn a lot of things. As earlier told, lean tools allows organization to focus on elimination of, generally there are so many wastes. Major things are about 7 wastes, which result in, if you allow that thing to happen, we get a superior quality, flexibility in operations, and minimizing the cost of the operation. This technique, which is pioneered by Japanese automotive company Toyota, if somebody visit that company in near Bangalore, they are fantastic lean tools. They are using it. All companies across the world have put this lean manufacturing tools to the use. Lean manufacturing tool is not a specific tool. It is a production practice that aims to minimize the waste and with entire value streams creating more value to the customers. It is basically a customer-based strategy which focuses on the value stream and its optimization. The main purpose of implementing lean manufacturing is to increase the productivity, thereby increase the profitability, reduce lead time and cost, and improve the quality, thus proving the utmost value to the customer. If you are cost effective, because in the international market, if you look at China, they are giving a lot of subsidies and all those things. Similar to that one, if you improve, put into place these tools, will be much more benefited. Presently, most of the SMEs are struggling with the elimination of the 7 waste, how to do it. Basically, 7 waste is transport, waiting for transport or movement of the goods inside the plant, inventory management, motion study and method study, as Dr. Satyanarayana was telling, then overproduction, waiting time for want of machine or want of manpower or want of testing, want of other aids, over-processing and defects, identification of defects. These type of defects will play a havoc if we miss it at the start. After the end product is there, then we identify the defect, the total cycle time is gone, total material is gone, total process is gone, time is gone, money is gone. Hence, in order to improve the productivity of SMEs, full-fledged strategy to implement lean techniques need to be devised. It may consist of various steps. First of all, everybody need not do the lean manufacturing tools. We should identify the manufacturing sector or a process industry in which implementation of lean manufacturing tools and techniques has not been extensively popularized and put them into use. Like as earlier told by Dr. Ranganath, just in time and Kanban, it was told by Mr. V.B. Singh, these tools also has to be put into use, and total machine breakdown also has to be considered. Total productivity, maintenance, overall equipment effectiveness can be used to track the availability of the machine, performance of the process, and quality in terms of number of rejects, what is a machine capability or human error or a process error. These things have to be done. These things, all tools cannot be implemented at a time. We can evolve a mechanism, we can evolve a roadmap. It can be done in a sequential manner to accept the ease. Suppose you go and tell the small scale industry, he is busy in his own thing. You want to implement this lean tools, he says no. Step by step, we can implement. We have to conduct the training to give the awareness of this lean manufacturing things. Standardize the process of waste reductions. As you are aware, the aerospace and defense manufacturing, which seminar was conducted earlier in collaboration with DRDL, we have told earlier also, has been identified as one of the most prominent sectors under the flagship program of Make in India, Atmanirbhar Bharat, to realize the US $5 trillion economy, Make in India, and aims to achieve 70% indigenous of the defense sector. Defense Procurement Procedure 2016 has introduced new procurement categories, which will be very much beneficial to the SMEs, like buy indigenously designed, developed, and manufactured. It is called IDDM, Make One and Make Two, to supplement the Make in India initiative, and inclusion of SMEs in defense exports have grown nearly to 7-fold in last 2 years, with an ambitious target of 35,000 crores in defense export by financial year 24 end. Policy reforms such as DPP 2020, defense corridors, and tax incentives are expected to boost SME participation. The defense manufacturing sector has a specific attribute. It's a long gestation period. There is only not a large scale production will not be there initially. It will be a batch production. Stringent quality requirements are there to meet the AS 9000 because they are all aerospace grade components, which is one-time use. Stringent timelines are also there. Very minimal defect or effectively zero defect, and there are likely initial during the development phase design changes will be there, which have to be incorporated and stage by stage. So if SMEs have to become an integral part of defense manufacturing sector, lean manufacturing techniques are the need of the hour. Lean manufacturing tools can very well address the specific requirements of batch production, stringent quality, timeline, timely delivery, and low defects. Hence, SMEs must strive towards implementing LM tools at the earliest so that they can become the integral part of defense manufacturing industry or automobile industry, aerospace industry. The options are very wide open. It is a win-win situation for the SMEs as well as the country as a whole. I once again thank Institute of Engineers for creating a platform and bringing experts to evolve a roadmap for implementation of lean manufacturing tools for productivity improvements in small and medium scale enterprises. I wish the webinar a grand success. Thank you very much.
Thank you, sir, Joshi sir, for giving us such a pragmatic and informative address. Thank you, sir. Now it's my time to hand over to Dr. G. Chandramohan Reddy, today's moderator of the event, to kindly brief introduction of the panelists. Over to Chandramohan Reddy garu.
Sir, good afternoon, all of you. Am I audible?
Yeah, please go.
Yeah. Satyadev Kashyap Nani. So here, when I accepted to take up this particular assignment, I was working as the professor and at CBIT, and then subsequently, when we are just moving towards organizing this particular webinar on productivity improvement in SMEs with the implementation of lean manufacturing tools. Last 2-3 days, I mean, I'm overburdened with the lot of work here soon after taking up the assignment of the principal. One moment. Is this, my video is not visible to me 1 minute. Okay. And yeah. So I am required to do some parallel work here simultaneously. Kindly excuse me for that because the job requires that I have to spend at 2 places. Good afternoon, all of you, once again. Today's chief guest, Dr. Jaideep Dar Joshi, the program director at DRDO Hyderabad, and then our own center chairman, Mr. Brahma Reddy, and then of course the key person who is responsible for organizing this or initiating and organizing this particular program, Dr. Satyanarayana, who is the chairman of Production Engineering Division, and then all other panelists and our own colleagues, of course, more importantly, Dr. G. Ranganath Ji, chairman, Committee for Advancement of Technology and Engineering, that's nothing but CARTE, and of course, Mr. V.B. Singh, who is the Vice President, Institution of Engineers, and of course, Dr. K. Saraswathamma, our own division committee member for the Production Engineering Division. Yeah, it gives me immense pleasure to introduce the speakers of the panelist as per the brochure that is available to me. Professor Dr. Rakesh L. Srivastava, who is the council member of IEI. And another speaker is Mr. Asim Inamdar, IVEX Lifestyle Vertical Expert, Indorama Ventures Limited, India. And then Engineer Hanumantarao, Additional General Manager, Usha International Limited. So I take great pleasure in introducing all the panelists. Without taking much of your time, I straight away request the first panel speaker, Professor Dr. Rakesh L. Srivastava, to commence his talk. Yeah, Dr. Rakesh Srivastava ji.
Srivastava sir, kindly unmute your.
Yeah, good afternoon. Good afternoon, everyone. Am I audible, sir?
Yes, sir, you are audible. Please go ahead.
Yeah. It's a wonderful afternoon, and I indeed am grateful to Dr. Satyanarayana, D. Brahma Reddy sir, for inviting me to be a part of this wonderful webinar for MSMEs. Now, productivity and lean tools. Many speakers have already talked about, the dignitaries have already talked about what lean tools are and what could be their importance to SMEs. So I would like to straight away go ahead with my topic, which is essentially Lean Six Sigma for small and manufacturing enterprises. So this is how the talk has been structured.
Your screen is not moving. Screen not moving.
Is it?
Yeah.
Is it now? This is the full screen now. Yeah. Is it fine now? Is it moving? Yeah.
Yeah, now it is moving.
Yeah. So this is how the talk has been structured. In fact, for this webinar, which essentially is focusing on lean manufacturing tools, I have basically opted to understand the audience as to what exactly is lean and how is it different from Six Sigma. So the talk has been structured basically to talk about what is Lean Six Sigma, which essentially consists of Lean and Six Sigma, and how are they relevant to SMEs. So this is the structure. We shall talk about what Lean Six Sigma is and how is it relevant to SMEs. Then we shall talk about what Lean is, and then what is this Lean Six Sigma. So Lean versus Six Sigma, how are the two different? And then the rest of the session, I would like to devote to Six Sigma. How did it evolve? And what exactly is Six Sigma? What is its relation with variations? And what are the goals of Six Sigma? How do we do it? And then if we can do it properly, what kind of benefits can SMEs and any other organization can get out of proper implementation and deployment of Six Sigma as well as Lean. Now, many challenges about SMEs and their role has already been talked about by Dr. Satyanarayanan, our chief guest, Dr. Jaitirth Joshi sir, and Dr. VB Singh sir, our vice president sir. So they've already talked about what are the challenges and importance of SMEs. I'll just take up a few. As you can see on this slide, friends, cost is one of the most important parameters when we talk about the survival and growth of any industry, specifically the SMEs, cost element. Because if the cost can be reduced, the opportunity to earn profit is significantly improved. Because cost is only something which is in our hands. The price is determined by the market. So it is only the cost which a producer can control. And therefore, if we can control the cost and reduce it, obviously, we can get higher profits for whatever products and services that SMEs are offering. So that's a big challenge. Then getting markets or customers is because of this stiff competition. Getting them is another big issue. Having got the orders, get them delivered in the time span, get them delivered in the specified manner within these specifications, the quality issues, and using all this with the available technologies, with the kind of manpower which is available before SMEs. Right? We have already been told that SMEs normally do not have the privilege of getting very highly skilled manpower. So whatever manpower that is available with SMEs, how can we hone their skills through these simple but very effective and powerful lean manufacturing tools. Many of them would be dealt with by the other two honorable speakers after me. So all of us will have a very good learning experience. So how do these lean manufacturing tools can help overcome the challenges before SMEs? This is what we shall try to learn today. Now, before we take up this Lean Six Sigma business, let us try to understand as to it is, as you can see, friends, it is directly committed to, first of all, the customers, then to the employees and the people who have put in the money in the enterprise, in the SMEs or MSMEs, the shareholders and investors, the owners, right? And then the framework goes beyond to the community and society and other stakeholders like the government, could be even the competitors, right? So it's basically trying to create a win-win situation for everyone. Before we try to understand what Lean Six Sigma is, let us be very clear about what it is not. So it is not a program of the month or week. It's not the job of quality department. It is not a magic bullet which can solve each and every problem that an organization or an SME faces. It is not simply a statistical tool and is not a certification system. So it is not all of these. So exactly what is it? Let's learn that. This is how the quality movement has taken place around the globe. We started with SQC or statistical quality control somewhere around 1920s and 1930s, with around World War I, which gave birth to quality circles, which were used vehemently in Japan, and from there they were adopted the world over. Then we had ISO 9000 standards, continuous improvement, Kaizen techniques, re-engineering, TOC or theory of constraints. Then National Quality Awards came into existence with the advent of Malcolm Baldrige National Quality Award, right? The prestigious US awards. There are several other Indian awards today on the horizon. TPM, our speaker talked about it earlier. Supply chain management, ISO series, lean manufacturing, and then Six Sigma came. And then came the Lean Six Sigma or Lean Sigma, which we are talking today. What will be the future? Any guesses from anybody? It's already there, friend. Now we are going in for Green Lean Sigma, right? We're already talking about it. Already lot of work has been done and people have started implementing Green Lean Sigma, which is the current thing which is happening in a big way. So if you look at the lean umbrella, as you can see, friends, every other business function is covered under this umbrella. So lean, if you learn, it could be employed to every function, every department of an organization. So it's a universal tool. It's a universal technique, can be applied simply anywhere under the sun. So that's a very important feature of lean manufacturing. Tools or lean tools, which could be applied to manufacturing as well as to every other operation, including all service operations. Now, what exactly is lean? All these lean techniques, they essentially evolve around these 5 lean principles, which have been shown on this slide. As you can see, these 5 principles are defining value, then making up the value stream or value stream mapping, as we call it, making the products flow through it. And who is pulling it? It is being pulled by the customer. It's not a push technique, but is a pull technique. Who is pulling it? The customers are pulling it, right? And this flow continues till it reaches perfection, right? So as you can see, it is a systematic approach to identify and eliminate waste, right? Through value stream analysis or mapping, by continuous improvement, by flowing the product at the pull of the customer, and we end up making it perfect. And perfect is not the end of the road, because perfection doesn't exist. The moment you reach a goal or lamppost, you already see another goal post before you. And therefore, perfection is always a journey. And so is lean manufacturing, or lean thinking is always a journey. It doesn't have an end. It is a continual pursuit to excel. So what is value to the customer? Now, when we talk about value, right, it could be value that is added plus non-value added, right? So obviously, a customer, value to a customer is what he is willing to pay, what he is willing to pay for. So obviously, customer is only going to pay for something which he is going to get in return through the services and products that are offered to him, right? So he is willing to pay only for value added activities, not for non-value adding activities. So what are non-value adding activities? Obviously, the ones the customer is not willing to pay for, right? And what are they? They essentially are waste. We call them as waste, right? So what is waste? Anything that adds cost and not value, right? And we know, friends, every activity costs us, and therefore the activities can be classified as value-adding activities or non-value-adding activities. Lean principles, they all revolve around identifying what are the non-value-adding activities and trying to make a system wherein the non-value-adding activities which have been identified can be either reduced or better, can be completely eliminated. So this journey of identifying and eliminating the non-value adding activities, which are only adding cost and not the value, is lean manufacturing or lean philosophy or lean principles. So in very plain, simple words, it is adding value and removing non-value adding activities. As simple as that, because non-value adding is in fact adding waste. So how does one classify or understand which activity is value adding activities? So there are essentially 3 criteria to decide whether an activity is value adding or is non-value adding. So what are those 3 criteria? The first, the customer must be willing to pay for that activity. So willingness on the part of the customer that he would like to pay for this activity. With this activity, the second thing is the part or object must change. There must be some change in the part or object. And third, it must be done right the first time and every time after that. Right? So unless until all these 3 criteria are met by an activity, it would be only then called as the value adding activity. Every other activity which doesn't meet these 3 criteria will be a non-value adding activity and therefore would be a waste. Right? And lean essentially revolves around adding only non-value adding activity and removing all non-value adding activities. And value adding activities will have all these 3 criterions or these 3 components associated with them. Coming down to Six Sigma, unlike waste elimination or value adding business of lean concept, Six Sigma essentially focused on reducing defects and improving quality. So that's how historically Six Sigma has focused on. So its focus is on reducing defects, right? By making the processes more and more robust, making it more and more quality focused. While the focus of Lean is removing waste or adding value, creating proper value streams which flow flawlessly in your systems to excel or to perfect, right? So if these two concepts, if they can be brought in together, it would be a wonderful thing to happen to our systems. And that's what has been done by making Lean Six Sigma as the overall basket, which will have several tools under its umbrella, right? So when we talk about Lean Sigma or Lean Six Sigma, which is essentially a marriage between the Lean concepts and the Sigma concept or Six Sigma concept, when the two concepts are brought together under one umbrella, it is called as Lean Six Sigma, right? So which is applicable not just for manufacturing, as was rightly pointed out, all these tools and techniques evolved essentially at Toyota, at Japan, right? And after World War II, the Japanese had lost the war and its economy was shattered. It so happened that some of the American gurus, they came to Japan and they changed the entire Japanese manufacturing once again. Toyota was the focal point there at that point of time, where most of these tools and techniques evolved. Japanese manufacturing techniques, they are called as, which evolved largely at Toyota around 1950s and 60s, right? So unlike manufacturing, where it took its birth, it could be applied to almost everywhere. It could be applied to administration part, it could be applied to sales, new product development and whatnot, right? And it is essentially integrating both Six Sigma and Lean concepts, right? And there's a lot of discipline, a very scientific approach, right? We can have clear roadmaps of their implementation, right? And we can act like a project management approach, select the tools which would be rightly utilized for a specific purpose and have the people trained and skilled for the purpose. So as has been already told, Lean and Six Sigma is essentially a very powerful marriage of Lean and Six Sigma. So Lean, focusing on eliminating waste, works on a principle of continuous flow, unhindered flow, and continually improving till you reach Excel and change the goalpost. Once one goal is reached, increase, move to the higher level and do it continuously. So continual improvement principles. So these are the basics of Lean, which is getting married to Six Sigma, which is variation reduction. If you can do that, you can improve your quality. You can control your processes better, and continuous improvement is something which is the basic tenet of both Lean as well as Six Sigma. So these two strong, powerful techniques or concepts, they have come together in this marriage, which is being called as Lean Six Sigma or Lean Sigma today, right? So improving speed, reducing reducing cycle times is what Lean is doing, and improving accuracy, improving quality. That's what Six Sigma is doing. If we can merge them together, we can have manufacturing excellence or better manufacturing performance. And productivity is a wonderful measure of measuring manufacturing performance. So if we can do this effectively, possibly we can get manufacturing excellence by improving our quality and productivity levels. So this is what we have discussed. Lean Six Sigma means adopting the tools under Lean as well as Six Sigma. This is how they work. So they are complementary to each other. They don't contrast. They help each other build up better systems. So what are the tools under these two distinct umbrellas, which under Lean Six Sigma become one single umbrella? So under Lean tools, value stream mapping or VSM, as it is called, 5S, Kaizen, Kanban, TPM, single piece flow, pull system, work cells, vendor management inventory or JIT. There are several of them. And under Six Sigma, we have essentially two approaches, DMAC and DMADV, statistical process control, failure mode effect analysis, capacity analysis, analysis of variance or covariance, design of experiments, and then Taguchi, which are advanced versions of the design of experiments, which try to optimize our processes. So this is the tools basket under Lean Six Sigma. And as has already been said, what is the application area of Lean Six Sigma? As you can see here, friends, practically anything and everything under the sun. Right from design to purchase, to marketing, to manufacturing, to maintenance, to quality assurance, to administration, to service, you name it, and you can apply the Lean Six Sigma to all these processes, all these activities. Any part of your system, you can apply it. Universal techniques. So with this brief introduction of Lean vis-a-vis Six Sigma, the rest, now I'll talk about Six Sigma, which I personally feel is equally important to relatively simpler Lean tools or Lean baskets. Six Sigma can also be easily and more powerfully employed by Lean, by SMEs. When we talk about Six Sigma, friends, it essentially revolves around three wisdoms, and those three wisdoms are given on this slide, friends. Right? The first wisdom happens to be the Indian wisdom. All of us, friends, all Indians have been brought up with this Indian wisdom about cause and effect relationship. We know that to every effect, there is a cause which is making an effect happen. So this cause and effect relationship, we have been taught right since 2000 BC. It's there in our culture. It's there in our bloodstream. Indians have been brought up with this, that nothing can happen on its own. Whenever something is happening, it is somebody or someone who's causing it to happen. So cause and effect relationship, Indian wisdom, the first wisdom of Six Sigma. The second wisdom is the German wisdom. And what was this German wisdom which the world knew around 18th century? This German wisdom says that variation is natural. Whenever you do something and come out with a product or deliver a service, there will always be some amount of variation in the end product. You cannot make it to exact perfection. There will always be some differences. There will always be some variation. And this variability is called as the inherent variability or natural variations. And they follow the normal distribution, the bell-shaped curve. All of us know about it, friends. Normal distribution, the bell-shaped curve. And this distribution says that this is the variation, the natural variation, the inherent variation. And the Germans, they taught to the world that this variation is bound to be there in everything, in every process that humanity tries in this universe. And there is a simple logic to this, friends. We know that why humans, whatever they do, will have inherent variation, because it is very, very natural. Because even the gods, their creations, we are all creations of God. No two trees or plants or animals or human beings are exactly alike. The twins also have their own differences. They're also not exactly alike. So when He, the Almighty, when He cannot produce the exact replicas, how can we ordinary mortals do it? So the moment, the earlier we accept this, that the variation is always natural, is universal, is bound to be there, the better it would be for all of us. This is what the Germans told the entire universe, the entire world around beginning 18th century. And the last wisdom came from quality gurus of the 20th century. They told us that when humans do activities, when they prepare systems and processes, this inherent or natural variability gets disturbed, right? And this also happens naturally. And this inherent variability, it gets worsened by causes that are spatial causes. They're not natural causes. The variations because of natural causes are natural or inherent variations. But if you see variations beyond the inherent or natural variations, they are spatial causes. They are the factors which we have put in the system. The humans have put in the system. They are of our own making, and we must put in efforts to identify them and remove them from our processes and systems. So this third wisdom was given to us by the quality gurus like Dr. Shewart, Deming, Taguchi, and so on. Right? So based on these three principles, friends, Six Sigma is led. Now, how was Six Sigma evolved? There's a very popular story. I'm sure many of you must be knowing about this, but before we understand that story, let me just tell you, we have already seen what Six Sigma or Lean Six Sigma is not. Now let's try to understand what Six Sigma is, right? Six Sigma means making fewer mistakes, producing almost defect-free product or service. If you can do that, you will be doing it at lower cost and producing better quality, right? And if you can do that, customers will be getting on-time deliveries. That will make them happy. And if our customers are happy, we will also be happy by improved profitability at our end. So that's how Six Sigma works, by reducing defects and making customers happy who make the producers happy. So a win-win situation. So the story of, so what Six Sigma is, there are a few terms. Let us understand these 4 or 5 terms which you are seeing on the board, on the slide. The first is critical to quality, CTQ, as we call it in Six Sigma. So what is CTQ? CTQ are the attributes which are most important to the customer. Now, friends, it's very, very important that customer is our king. We exist, organizations exist, if their customers exist. If any organization doesn't have the patronage of its customers, it has no reason to stay in business, right? So customers are the kings, and we must start looking everything at our systems, at our processes from the eyes of the customer. And therefore, critical to quality are the attributes of our products and services which we are offering to the customers. and which customer feels are the most important things which he wants from us to be delivered to him or her. So they are those most important attributes or characteristics of the products or services which are being offered to the customer. Defect is failure to meet the customer needs, right? Failure to meet those important customer attributes or characteristics. It is a defect, right? Because customer won't accept those products which doesn't fulfill his desires or his needs. Process capability is the capability of our processes in terms of what can they deliver. Can they deliver what the customer wants? If yes, we have a fair chance of staying in business. If our processes don't have the capability to deliver what the customer wants or what customer CTQs are, we will be not surviving. We will be a failure entity, right? We will not be accepted by the customer, right? So we have to make our processes capable to deliver what the customer wants. So process capability, the third term that we have learned. Now variation, the fourth term, what the customer sees and feels. As I've said earlier, we must look at our systems, our products, our processes from the way the customer sees and feels it, right? We must get into the shoes of our customers, right? And should not blah blah ourselves, right? That we are doing this, we are doing that, we are doing that. Get the feedback from the customer. What he says is most important, what we say is important, right? So try to look at from the customer, the variation in terms of delivery, in terms of product quality, in terms of promises made to the customers. Variations must be within the customer limits, right? They cannot be more than what customer can adjust or tolerate. And finally, the last term, stable operations. We are in a world which is continuously changing. So as we have accepted that the variations are natural, let us also accept that change is also happening all around. Change is also constant, right? And if this is true, then obviously our systems, our processes will also change over a period of time. And it has been statistically proved, friends, that a process or the system that we work in, they also change over a period of time. And as we advance, we'll know how much is the natural change which is happening. Beyond, if our processes and systems are changing beyond these limits, the change won't be natural, right? So we'll understand about it. But first of all, stable operations means our operations and systems which are changing within the natural boundaries of change, right? So those processes would be called as, or those operations would be called as stable operations. So therefore, the Six Sigma is, I'm sure all of you know about the Six Sigma level. It is 3.4 defects per million opportunities, right? So making 1 million is about 10 lakhs. So 3.4 defects in 10 lakh opportunities, right? In terms of percentage, it will be 99.99996%. Right? So that's what Six Sigma standard is. And Six Sigma, friends, is basically your process capability, your system or your processes that are which level. They could be at 2 Sigma level, 3 Sigma level, 4 Sigma level, 5 Sigma level, or 6 Sigma level, which are most desirable, because Six Sigma is absolutely very near to perfection, almost defect-free, 3.4 defects per million opportunities. 10 lakhs, how many defects? 3.4 defects, nearly perfect, right? So there are several examples given. We'll take up the last one, the example in terms of distance, to understand the difference between 3 sigma, 4 sigma, 5 sigma, or 6 sigma levels, right? So the coast to coast distance, the east coast to west coast distance of United States of America, which will be roughly about 2,500 to 3,000 kilometers. If that distance is treated as 3 sigma level, then the 4 sigma level would be 45 minutes of freeway driving in any direction. If we have a car and if we move it at say 100 kilometers per hour, then 45 minutes will be moving about 75 kilometers. So, right? So from about 2,000 to 3,000 kilometers at 3 sigma level, we have come down to about 75 kilometers at 4 sigma level. What will be 5 sigma? That will be a trip to the local gas petrol pump. Nowadays, a local petrol pump we can find in about 2 to 3 kilometers. Even in smaller towns, we can get a petrol pump in about 5 kilometers distance, right? So from 75 kilometers at 4 sigma level, it has come down to about 5 to 6 kilometers, right? Or 2 to 3 kilometers. At 6 sigma level, this would be taking 4 steps in any direction. Even a 6 feet person, right? If you take a stride, no more than 1 meter, right? So in 4 steps, about 4 meters. For most ordinary citizens, it may be about 3 meters. So from 2 to 3 kilometers, we have moved down to about 4 meters or 5 meters, right? So that's the level change with, this seems to be a linear scale, 3, 4, 5 sigma, but sigma scales, there is a tremendous difference, right? As we can see pictorially in the next slide. You can see these pictures, I believe. So if that 2 sigma, if you look at that big red circle or ellipse, right? That is 2 sigma level. Then 3 sigma level is that smaller circle. 4 sigma, further smaller. 5 sigma, simply a dot. And 6 sigma, I'm a 60-year man, very difficult for me to see that small point there, but I'm sure the younger crowd here, the younger audience here would be able to locate that. That will be 6 sigma. Quantitatively, the same thing has been put. In terms of out of 10 million, out of 1 million means 10 lakhs, 2 sigma is about 3 lakhs, means 30% defects. 3 sigma, it is about 66,000, roughly about 6.6%. At 4 sigma, it's about 6210 defects per million opportunities. At 5 sigma, it is 233, and at 6 sigma, it is 3.4. So as we move down the sigma scale, friends, so as you move from 3 sigma to 2 sigma to 3 sigma, you have moved 5 times, 3 lakhs to 66,000, 5 times improvement or defect reduction. 3 sigma to 4 sigma, roughly about 10 times. 4 sigma to 5 sigma, roughly 20 times. And from 5 sigma to 6 sigma, about 80 times. That's the power of 6 sigma, friends. The sigma scale looks linear, but the reduction in defects are not linear, right? They are absolutely magical. That's the power of 6 sigma. Now the story about how did and where did it evolve. This was early 80s, friends, 1980s. The Japanese had recovered from their World War II loss, the gurus there and the Japanese culture had made Japanese manufacturing very, very powerful. The Japanese companies were conquering the world, and Americans were losing out to the Japanese. It so happened, friends, that one of the Motorola plants, which was manufacturing television sets at that point of time, right, this was acquired by a Japanese firm. And a miracle happened. What changed was this Motorola plant saw a change in management. Earlier, it was American management. Now it was Japanese management. The product, the process, the tools, technology, and the people, they remained the same. The only change was management. And Bill Smith, who was a big engineer at Motorola, he experienced the change because of this management transfer from American to Japanese. What he saw that the defects in the products, the TV sets which this company was manufacturing at that point, with this change in hand, the defects were reduced 20 times. I'm saying 20 times, friends, means 2000%. This was a miracle to Bill Smith. And he came to know, he understood that there is something terribly wrong with the way the Americans are manufacturing, are managing their plants and their processes and their systems. So he started introspection. He went deeper into their processes, and Six Sigma was born. So that's the story of evolution of Six Sigma, somewhere around 85, 86 at Motorola. And soon GE acquired it. Several other Allied Signals adopted it. It was adopted by the Western world. And through GE had a tie-up with Wipro, their electronics product division. So Wipro Electronics Division, they brought it to India somewhere around early 90s. Through GE, it came to India. And now Six Sigma is there, even in many medium scale enterprises, if not small scale. There are some small scale industries also who have adopted Six Sigma and have benefited tremendously out of this. So that was a small story of how Six Sigma evolved. So what is Six Sigma? Right? We know, friends, all activities, we must look at it from the point of view of a process. And what is a process? A process receives certain inputs, and these inputs are provided by the suppliers. As you can see on this slide here, suppliers are giving the inputs. Inputs are getting into the processes, right? And the end product of the processes are the outputs, which could be products or which could be services, which are offered to the customers, right? Depending upon their requirements. So this is the process model of our systems, of our activities, right? And if you apply to this model, the first, the second wisdom, which was the German wisdom, that all of them will have inherent variation. So you can see here, friends, the suppliers will have their own variations. Inputs will have therefore their own variations. The processes will have their inherent variations, and all of them combined together would be getting into the products or services that we give to the customers. And therefore they will have their variations, which you are seeing in our products and services. And the customer at the other hand will have his own requirements and needs. He will have his picture of variation which is acceptable. Right? So what is important? Customer is the king, market decides what is required. And the producers have only got to deliver what the market requires, what the customer requires. So whatever imagination, whatever needs a customer has, a manufacturer has to deliver that. His processes, his systems must deliver and must match the variation pattern of the customer, right? So therefore, the process capability is important. A manufacturer, a producer has to match its processes, its system to exactly what is required by the customer, right? And therefore, we say that process mapping is that important because it has to have a perfect match with the requirement of the customer, because the requirement of the customers are the dictates, they cannot be changed. We have to change our systems and make our processes capable of delivering and matching those requirements. So this is how Six Sigma is applied to processes and systems. Going further on this, so this variation is obviously caused because of some factors, which are natural factors, access, right? We call them as access, right? So there'll be some access of the suppliers, some accesses of the inputs, some accesses of the processes. All of these accesses will combine themselves to deliver a product or a service which will have its own pattern of variation because of these accesses, which are under our control. Accesses are under control because they are of our making, right? And here we have a customer whom the products and services have to be delivered, which are the output of our processes. He is having his own demands, a big why, right? His variation pattern, his limits and tolerance, which is set by him, which we have to fulfill. Then only our products and services will be acceptable and we'll survive. Because if we don't it, there are several competitors who will make that happen. Right? So we've always got to be one step ahead of our competitors if we really want to capture the market. Right? And therefore, most important point is this variation which is there in our systems caused by these access which are in our control. We have to know which are these access which we call as the culprits which are causing this variation, and this variation has to be within the variation of required or demanded by our customers, the big why, right? And therefore the Six Sigma equation becomes y is equal to fx. Y is not in our hand, decided by the customer or the market. The only thing which is in our hand are these axes, right? So we must combine all these axes in our systems so as to give a product which is equal to y. So all these combinations, fx is under our control. We have to match our fx with the y, which is given to us, dictated to us by our customer or the market. So that's Six Sigma of process. That's how Six Sigma works for us. So essentially working out this equation for our system, we do it through Six Sigma, right? So by evolving this equation for our system and processes is Six Sigma. And we know, friends, that these equations can take several forms, right? From simpler ones to more and more complicated ones, right? So we have got to come up with the exact equation for our system, for our organization's systems and processes, right? This Six Sigma help us evolve. This equation, Six Sigma helps us evolve. Right? So this pattern which is required by the customer, Y, this big Y, must be met by this FX, right? So this is how variation is important and how this variation is related to access and at any point of time. Yeah. We have seen the difference between 2 sigma, 3 sigma, 4 sigma, like that, right? But what is the sigma of a process? Now let us define the sigma of the process. It's time to define the sigma of the process.
Rakesh, you have to see the timing also.
So I'll finish in another 10 minutes. Will that be okay?
I think already we are behind 15 minutes behind the schedule.
Yeah,
Try to
fine. So
finish by 5
will
minutes.
10 minutes be okay with you?
5 minutes, sir. 5 minutes because other
5
two
minutes?
speakers are there.
Fine. Right, sir. I'll do that.
Fine.
Thank you. Thanks for reminding. So let's very quickly define what is the sigma of the process. The sigma of the process, what I am showing you here is the natural distribution, Japanese wisdom, right? Normal distribution curve, the bell-shaped curve, right? You can see here, all of us would want, the customers would want the products to be delivered at the target. But we know that is not possible. So this is what our process curve is. This is what is our process behaving, right? And standard deviation, sigma. So how many standard deviations they lie between the target and the customer specification, between the red line and the white line, the target. Between that distance, how many standard deviations of our process are accommodated? That is the sigma of the process, right? So as you can see, friends, the upper one here, this is a 3 sigma process because in this distance, we have 3 sigmas getting accommodated. While the process here is a 6 sigma process because the standard deviation, 6 standard deviations are getting accommodated in the space which is provided by our customer, right? So obviously, when we make a 6 sigma process, then it will be almost no defects. While a 3 sigma process, 99.97% accuracy. So obviously we would want to increase, go to 6 sigma. So how is this journey from 3 sigma to 6 sigma? Let's have a look at this journey. This is the journey. This is the journey from 3 sigma or any sigma to 6 sigma. How did you find this journey? As you can see, friends, it is not a journey which can be completed overnight. It will take years and years. It will take several efforts, several attempts, lot of complexities, lot of knowledge, lot of technology would be needed. A lot of wisdom would be needed to move from 3 sigma to 6 sigma. It's a very, very difficult journey, friends. Let me tell you before. It's not an easy journey. So obviously the goals for us would be to take our systems and processes as close to 6 sigma as possible. And this is normally done through DMAC. Most popular technique, DMAC, define, measure, analyze, improve, and control, a 5-phase technique. Very quickly, we'll go through this. Define, measure, analyze, improve, and control. These are the 5 phases under this methodology, DMAC methodology of 6 sigma. What do we do define? In define, we exactly do where we are, right? We try to find out what is our current level Where are we? Are we at 2 sigma level, 2.5 sigma level, 3.5 sigma level? Where are we? Right? So define where we are. Having defined that, we move to the next phase, measure phase, where we try to find out where we are in terms of and what, right? What level are we in? Okay. And analyze phase, we try to find out why we are there, where we are. If we are at 3 sigma level, why are we there? Who are those axes? Who are those culprits who are not allowing us to move ahead? Who are stopping us at 2.5 sigma level or 3.5 sigma level, from which we want to break and move ahead? So this analysis of root causes, finding out those axes, those culprits, analyze phases there. Having done that, we come down to the next phase, which will be the improvement phase. Having identified those factors, those axes, those root causes who are stopping us not to move forward, we now know that these are the culprits. Now we try to find out how to take care of these culprits, right? So that our processes improve, we move higher. So we develop solutions. We validate those solutions that yes, this is how these culprits can be taken care of. And if we can take care of these culprits, these solutions can be implemented. Our process sigma will improve. With these solutions, we move down to the last phase, which is control phase. Now, these solutions were done at a pilot level. We now, in this control phase, these workable solutions, we put them at the entire process level, at the entire operational level, and see to it that they deliver as they were delivering at the pilot level. Having done that, the project team would come out of, will deliver the improved process to the process owner and come out of it. So that's how Six Sigma works, the DMAC process. There are several tools. I don't think we'll take some other time to discuss this. The benefits, let's do it. So essentially, when we do this, what do? We improve the quality, product as well as process quality, which will internally improve our productivity, and externally it will improve. So that will reduce our costs. Externally, it will reduce the price. And if both of these happen, it will improve our profit, which will improve our market share, right? Because our customers are now better satisfied. So this is how Six Sigma works. And these are the various levels, 3 Sigma, 4 Sigma. As you move up, the things become more and more complex. You are required to move up to higher and more complex tools, right? Story doesn't remain simple. 3 Sigma, 4 Sigma level, low-hanging 7 basic tools will do the job. But beyond 4 Sigma, it's very, very difficult, very complex phenomenon. Who would do it? So this is how the people, so the trained people, they're given belts level. So smallest belt is white, then yellow, then green, black, and then the master black belt. I am a master black belt, right? And then there are process executives, systems executives. Executives are the top management, champions are the middle ones, and process owners are the people under whose processes are improved, right? So this is all about this. So here, I would like to end. If there are any questions, I would welcome them. Thank you so much. You can ask questions for this. If there are any questions, I would love to answer. Any questions, please?
So this all, what you explained is the total meaning and the total about the Six Sigma evaluation and other things. Sir, suppose this is to be implemented in the company, what are the steps to be taken?
So for Six Sigma implementation, as I have said, you need to have skilled manpower. You have to have training given to your employees, white belt training, yellow belt training, green belt training, and black belt training, right? So there is a training process, right? Master belts are the people who normally provide these trainings. Like I also conduct several training programs as a master black belt. So, and then the project teams have to be formed, which will carry out these projects, DMAC projects, define, measure, analyze, improve, and control. So it's a project-based system.
Okay, sir. Thank you.
Thank you so much, sir. Thank you so much. Any other questions? If there are some. My other panel speakers, they're going to talk on several lean tools. Mr. Asim Inamdar, a practicing lean consultant, and Mr. Hanumantara, they're going to discuss lean tools and would go into greater depths of some of the tools.
Thank you, sir. Thank you, Srivastava sir, for your excellent. I think you have not left anything in Six Sigma to even ask question, because so much information and very rich examples you have wonderfully explained. Thank you so much, sir. So because we are also running short of time, I'm having a committee meeting at 6 o'clock. So I have to hurry up for the two speakers. And excuse me. Thank you, sir. Thank you. And now it's my privilege, as our moderator had some urgent work and he has left for time being. I have taken over again back from him, and I would like to introduce. It's a privilege for me to introduce Engineer Asim Inamdarji. Is a graduate in engineering and is MIT from Pune, post graduation in mechanical engineering. Is a MS from Industrial Engineering in Texas, USA. Is a research associate, University of Texas, El Paso, from 2004 to 2007, and is a manufacturing engineer, Cummins Limited, Texas, USA, 7 and 8. And manufacturing engineering specialist roles, Rolls-Royce Energy Systems, Texas, USA, 2009 to 2015. Is a quality manager and black belt, Rolls-Royce Energy Systems, Texas, USA, 2012 and 15, and also is a manager in BFL Excellence Bharat Forge Limited, Pune, India, from the year 2017 to 2020, and presently is the head of the quality machining division, Bharat Forge Limited, Pune, India, 2021, and now he is he has had his own company, IVX Lifestyle Vertical Export Indorama Ventures Limited, India, since 2022. And he has got a long professional summary also. And he has attended many key projects like Lean Project, Lead Time and Reduction, Cummins Limited, USA. And as earlier explained, at DMAC project, and that as he has done from the Rolls-Royce Energy Systems, Texas, USA, and PIP shop for transformation and other lead lead time reduction, Kaizen with the cross-functional team members, and in pipe fabrication area to achieve 30% improvement in capacity and 40% reduction in lead time and 50% reduction in distance traveled, thereby saving $500 okay for the year. And thank you, sir. Asim Inamdarji, it's my privilege. I had a privilege to introduce you. Now, may I request you to kindly present your talk, sir, today? Hello. Hello. Sir, we are not getting your audio.
Sir, we are not audible. We are not audible.
Okay, can you hear now?
Yeah,
Yeah.
now it is there.
Okay, okay. Thanks for the long introduction. I have not done anything great. Just was fortunate to work with different companies throughout the world. Actually, I did my bachelor's in mechanical engineering from Pune, and then I did my master's from the industrial engineering from Texas in USA. And then I worked for a couple of companies in US. One was the Cummins Limited, and then was able to work for the Rolls-Royce Energy Systems. So the two companies where I worked over there, and that's where I started my journey of lean manufacturing, or the use of lean manufacturing tools. Can you see my screen now?
Yeah, it is visible, please. You can go ahead.
Okay. So first I would like to thank the Telangana State Center and the Institute of Engineers and all the dignitaries today, all the speakers, my colleagues, and all the attendees. So giving me this opportunity to talk today. And without spending any time, I'll go directly to the topic. So today's topic now is productivity improvement for the SMEs with implementation of lean manufacturing tools. And I think Dr. Srivastav has very informatively given us information about the Six Sigma methodology. I won't be spending much time on those. And if there is some information in my slide which is repeating, I'll just quickly pass through that because of the time constraint. And I will try to focus on the things on the lean tools more than the Six Sigma. So as Jack Welch, who was the CEO of General Electric, he has said that speed is everything. So it is the indispensable ingredient to competitiveness. So basically, lean is about speed. So how we can move our product as fast as possible through any process. So that is mainly the function of the lean tools. And that's what we will see. So we'll see today. So what I am going to cover is basically some of the lean manufacturing tools and principles, which I think Dr. Srivastav has already covered. So we'll quickly go through that. And then I'm going to focus on mainly two tools. One is value stream mapping, and then the another one is single minute exchange of dice, which is called a SMED. And I'll give you a couple of examples from my experience, where I was able to use these tools in the industry. So that will help the audience to understand how we can use. So a little bit theory about the tool, and then how we can use it in the industry. So that will be my agenda. So basically, when we talk about lean, like I said, it is about speed, and it is about eliminating waste and improving the cycle time of the process. So in our daily example, and let me start with saying that lean is more about common sense. So which unfortunately is not so common. So like you saw in the previous presentation, what Six Sigma is, it's more about statistics. It's more about skilled manpower. It's more about the training. It's more about the knowledge of the person. Exactly opposite is lean, where you don't need that much like theoretical knowledge, I would say, but you would be street smart in simple terms. You should be street smart. You should understand what the process is. And the main thing about lean tools is going on the shop floor and hands-on working. That is the main thing about lean. So in any lean tool you take, unless you are on the shop floor, unless you are on the gemba, which is a Japanese word for the place where the problem is, you will not be able to use that tool effectively. So in any tool, let's say VSM or let's say 5S or SMED, any tool you take, you have to be hands-on and you have to be on the shop floor where the problem is, and that's when you will be effectively solving that problem using that lean tool. So that is very important thing behind using lean tools, is you have to be hands-on. And then the next important thing is about the people. So how you involve the people into this using lean tools. So though with those two things going in your way, I think your organization or your institution or wherever you are applying these tools, definitely you will get success. And that's what like I have learned, and that's what I have seen. Like when I got my opportunity to work with Cummins, it was just after my master's, and they had hired me as a intern. And that time I was fortunate. It was a very small plant, and I was able to work hands-on on the machines, and I learned the issues firsthand. And that's when same time I was learning the lean manufacturing tools just by myself. Like I just reading the books and trying to use the concepts on the shop floor. And that's when I was able to understand the use of those tools and how hands-on experience is important. So that is very important. And this was like Srivastavaji said, that it started with Toyota in about 1950s. Taiichi Ono is called as the father of the Toyota production system, where most of these tools were implemented or found by him and implemented in Toyota in their production system. So lean is basically a very good support for the Six Sigma, where it can eliminate this waste and improve the quality, and where Six Sigma also complements lean by improving the speed of the process. So if you use these two tools in conjunction, you will definitely get the benefits. So I think we will not spend much time on this. We already seen this in the previous presentation, like what are the 5 principles on which the lean manufacturing works. So basically the first step is defining the value. And what is the value? We have already seen that whatever the customer demands or whatever are the customer expectations, that basically is the value. And then you map that using that value, you map your value stream. We'll see what is value stream. Then you flow your product through that. And like Mr. Srivastava said, that you have to pull this thing. So it's not basically you just produce and then try to sell the product. It's about how much demand you have from the market, and then you produce just to meet that demand. And then you continue with this cycle until you achieve your perfection. So these are like the 5 principles on which lean manufacturing works. And then there are various tools. Here is just few of them which I have shown, like 5S or TPM or Kanban, SMED, single piece flow, value stream mapping. But there are a whole bunch of other tools under lean manufacturing which can be used also. So basically, what are these principles and how do they work is we have to always strive for excellence instead of perfection, because perfection can be costly. So in order, if you just go behind perfection, then it can be a lot of expense. And so strive for excellence and you will get the benefits of that. Shape your processes based on the importance of your customer. So just whatever customer wants, define your processes based on that. Map your processes to minimize the necessary waste and eliminate the unnecessary waste. So you don't want any waste in your process, like we have seen in the previous presentation, the 7 wastes, or actually in our company, we have now gone to 9 wastes. So we'll see what are those in the coming slides. Then planning and production. So planning is very important in lean manufacturing, because if you go and directly jump into the problem without any planning, then it can create whole other sorts of waste. So planning is very important. And always try to use the pull systems. So we will, in our next slide, we'll see some of the pull systems. What are those? And then try to be as much visual as possible. So lean manufacturing works very well with visual management. So anything which you can make visual will be very easily understood by any layman who is working over there. Even if it's a contact person, even if it's a worker without any academic knowledge, if you make it visual, it will be easily understood by everyone, and that will make your process much more defect free. And then you should stop the production as soon as you identify a defect. So you don't allow to continue to create the defects, because anything up to that point is a waste. And as much as you continue with that, then it will cost the organization. So stop the production as soon as you see the defects. And most importantly, you think in terms of system. So a lot of times when I work with the shop teams, and when we are working on certain problem, and when we are doing the root cause analysis, usually it comes down to some person has done a mistake, or that worker was not trained, or that worker was new and he was not trained. So usually it comes down to a person, but try to not get down to the person. So you need to get down to the system. So the root cause should always be some kind of system. So if you fix that system, you are sure that the problem will not repeat again. And that's where you should think always about the system. So lean philosophy always aims to provide new ways to think, to deliver more with less. That's what the moral of this slide is. So when we talk about waste, there are now actually 9 types of waste. And if you just want to remember all these 9 types of waste, there is an acronym which is called as downtimes. So downtimes, every letter of that word defines one type of waste. So D is defects, O is overproduction, W is waiting, N is non-utilization of talent, T is transportation, I is inventory, M is motion, E is excessive processing, and then S is basically what we have defined at our company as safety lack or lack of safety, because that also creates accidents, that also creates wastage of time, because now you have to get involved into the person who has been involved in an accident. You have to take him to the doctor. So all these waste starts accumulating when there is a safety incident. So lack of safety is also another kind of waste. So waste is basically any action or step in the process that does not add value, that we've seen in the previous. So we want to, so the main purpose of any lean manufacturing tool is try to identify this waste. So first is to identify this waste, because a lot of times when I go and talk with the shop teams and I ask them, what is the waste? So usually people are thinking about the quality waste, like whatever the product is defective, or if they have reworked at the most, then they will think that that is a waste. But nobody thinks outside of that waste, like all these other 8 wastes which we have seen. Nobody thinks that, and if you don't think, then you don't identify that, and if you don't identify, then you can't fix that. So once people are aware about all these other wastes, they start to identify those wastes, and then we can have actions to eliminate those, and that will give a huge benefit or impact on your bottom line. And this is a very fast way to improve your bottom line, because once these are very small things which you can implement, very small improvements, but those are very effective, and in very quick time you will see the improvement in your bottom line results. So maybe in 2 or 3 months you can see drastic improvement in your defects, drastic improvement in your productivity. So using this and identifying waste is a very important part of lean manufacturing. So like Bill Smith has said, if you want to improve something, then involve the people who are doing the job. So lean manufacturing is all about people, how you are involving people, how you are training them, how you are giving awareness to them about all these different ways. And then once they get this idea, I think they will get hold of all those things, and they will be empowered to fix those things, because it doesn't need any rocket science to work on this. So any person, any worker on the shop floor, if you tell him all these tools, he will start identifying these, and because he's working there day to day, and he is facing issues which, even like if I am sitting in the office, I cannot see what pain he's going through, but he is experiencing that pain day in, day out. And if you make him aware of all these different tools, then he will identify all those difficulties which he's facing on a day-to-day basis. And those are the things where you need to focus and fix those things, because he's the best person to tell you all those things which can be fixed. And even if you do any analysis, any statistics, we will not be able to find these things which the people are experiencing on the shop floor. So that is the most important thing which we need to keep in mind. So now let's start to go deeper into the value stream mapping tool. So first thing, before we get into the value stream map, we need to understand what is the value stream. So basically, like Taishi Uno had said, basically what we are doing is looking at the timeline from when the moment customer gives us an order, and then up to the point where we get the cash from the customer. So the whole process from getting the order to getting the cash from the customer, that is the whole value stream, where we are creating value at every step of the process. And if we can draw that, or if we can show that on a piece of paper, I think that becomes a very effective tool. And people are really amazed when they see a whole value stream map showing all of this value stream. And then you can basically identify all your waste on that one paper. You can put all that on one paper, and then you can work on the small improvements, work on the big issues, and everything is on one paper. So basically a value stream is a flow of materials. That is one thing. And then also you document the flow of information, how the information is flowing through the process, because there are a lot of times there is issue on waiting because of the document didn't come on the time, or the information didn't come on the time, and then it is causing the process to hold. So if we can understand all that, then that is the whole value stream. So if we can make a visual representation of all this on one paper, then that is called as a value stream map, basically, simply said that. And we have already seen what is value added and what is non-value added, so we don't get much into that. Value added is like we have seen 3 different criteria. Customer is willing to pay, it is done right first time, and then there is a transformation of the product in that step. So if these 3 criteria are not met, then it is a non-value added activity. So remembering that, we move further and we see how this value stream map is now actually done. So we'll get into that. So there are different components of the value stream map. There are various symbols that are used. And then there are various steps how we want to create this value stream map. So we'll go through that. So there are different symbols when we start putting together this visual value stream map on paper. So first thing is, and we'll go to the steps how we are going to create that value stream map. But before that, we can look at some of the symbols, like how is the process step defined. Highlight. Okay, so Basically, how is the process step or activity shown on the value stream map? Then there are data boxes on the value stream map where you note down key data like the cycle time, lead time, changeover time, how much scrap or waste is in the process, how many operators are there. So all that important information you document in a data box. What is the inventory between two steps in the process? How are the shipments? How is the material moving, whether it is a push flow or whether it is a pull flow? Are we using a supermarket? Are we using Kanban? So all this, and then also there are symbols for the information flow, where whether the information is being manual or electronic, like whether we are giving the information through email or through any software like SAP. Are we using like production Kanbans or withdrawal Kanbans? Is there any area for the Kanban posting? How are the Kanbans, whether they are batch Kanbans or single piece Kanbans? How are we level loading? So all these different symbols we are using to make a visual picture of the value stream. So purpose of the current state map. So when we start with our value stream mapping exercise, we first create a current state map. So the current state map is we just go on the shop floor and we start from the customer end and walking behind or walking downstream to the supplier. And then we are mapping every step. We have a paper and a pencil in our hand, and we are drawing that on the paper as we walk through the process. So it's actually drawn on the shop floor. It's a rough diagram, and now there are softwares and everything for doing that. But initially you have to take a paper and pencil and walk on the floor to create that. So that is the basic thing. And the purpose of that is mainly where is our inventory built into the process, because a lot of times we have information in SAP or we have information in Excel, but that is not real time. That is maybe 1 day old or maybe 1 shift old. And if you go on the shop floor, you will really see where are the piles sitting. A lot of times there are products sitting on the floor which are just sitting there for months because there is no demand, and those are nowhere in the reports. So once you walk through the shop floor, you will start seeing the actual waste which is lying in the process and which is not visible in any of your reports. So it's called as a hidden factory. So there are a lot of things where you will discover when you are doing this Gemba walk, and those which are not identified or given in any of the reports. So then what are the cycle times? Where are the bottlenecks? So all this information we start finding once we start putting this value stream map or the current state map together. So what are some of the rules? Like I said, it has to be on the Gemba, it has to be hand drawn, it has to be with a paper and pencil. You have to walk the shop floor. You start with your customer and then you go backwards. So while you are going, you note down different observations. Where is inventory? What are the bottlenecks? All the data what you want, you can record during your Gemba walk. You talk with the operators. You identify what are their difficulties. Note down those difficulties. So that way, all that information starts accumulating in your value stream map. So that way, once you are done, you have a whole bank of information about the small improvements or opportunities that are lying in your value stream. So that is how you or some of the rules for creating the value stream map. Then if we go step by step, like I said, we begin with the customer. So need to collect the statistics, how much units are being shipped, what is the demand from the customer, so we can get maybe last 6 months data. What is our production or capacity, so we get that data. So start with the customer, then start slowly come down to your process within your facility, and then start collecting information about the process. So how the material is flowing, so you can watch it yourself. And then you start accumulating or adding data into the data boxes. So like here, what is the cycle time of the step? What is the changeover time? How many shifts that particular step is working? How much scrap is there? How many people are working in that particular step? So all that data, what you think important, you can start noting down under that process step. Then you add the inventory levels. So if there are 2 steps here, then what is the inventory between those 2 steps? Get that from you get the actual inventory. So usually when I'm doing this value stream map, I see like 100 parts which are lying in between the 2 steps, and I ask the production in charge, okay, what is this inventory? So usually there is the answer is very common every time that, oh, this is just today. There was an issue and this is just today, but otherwise if you come any day, then there is no inventory in between that. But you don't go by the comments, you just take the actual facts. Whatever is lying in the process, you just take that number and put it on the paper. So whatever you actually see on the floor, you put it on the paper. Then you go downstream up to the start of your process and then go to the supplier, collect the data from the supplier. So what are the delivery schedules of the supplier? Is it daily, weekly? How much inventory you are carrying in your warehouse? How much inventory the supplier has? And once you get all that information related to material, then you start adding the information flow. So how is the information flow? Like, what are the production schedules given to the production? Are they daily? Are they communicated by email? Or are they verbally communicated? Are there any changes in the schedules? Because if there is any changes in the schedules, then production has to work on that. And then there is again so begin with the customer and then work back through the process. So that is the summary of basically how we draw this value stream map. And then finally, once you get all that data, you add a timeline at the bottom of the map where you show the processing time or the cycle time for each step, and then also the lead time for that step. So once you have all that information, then you can add up all the processing times for every step. That will give you the total processing time, which is mainly the value added time. And then if you add all the lead times, that is your value added time plus your non-value added time. So if you take the ratio, then that will give you an idea of basically what is the process you are working on, what is the ratio value add to non-value add the process is working on. And like what I've seen is the best of the processes, even like the Toyota processes, they are working on this ratio of around 15 to 20%. So even those processes, they have 80% of opportunity of eliminating waste in their process. And that's why at Toyota, even today, they are working on continuous improvement, because there is this whole opportunity of 80% of the waste in the process, which is now hidden. So it's not easy to find, but it's hidden. But unless you walk down the floor and unless you see for yourself, you will not be able to identify that and try to reduce or eliminate that. So that is the opportunity where once you complete this value stream map, it will be it's like a shock to the production guys. Like when you show this value stream map and show this ratio, they won't believe that like they are running the process at such a low ratio. So it's very difficult to convince them, but basically you have to be positive by looking at that as the improvement opportunities rather than blaming them that the process is not running to what is expected. So it's the opportunity where you can add value to your organization and fix those things, eliminate the waste, and that will improve your productivity.
Mr. Singh, we got 10 minutes time, sir.
10 minutes.
Yeah.
Okay, so then I think we'll be able to complete one tool. So we'll at least complete the value stream mapping.
Please.
Yeah. So then basically the value stream map works on the takt time. So what is takt time? So takt time is basically available working time divided by the customer demand. So whatever is the available time, if it's 1 shift or 3 shift operation divided by what is the demand, then that will be your takt time. So for the example here, the production allows customer 168 hours or 7 days to make 400 tons of the material. So the takt will be, if you convert this into minutes and then this into the kgs, then your takt will be 0.02 minutes per kg. So basically what it is used is every step in your process should be able to meet this takt time. So anything over this takt time, you will have to work on that, and that will be a bottleneck. So it will clearly show which are the bottlenecks in your process, which are not meeting this takt time. And then you basically work on that and try to bring those below this takt time. So then some of the VSM guidelines are like we produce to the takt time because that is directly coming from the customer demand. Develop continuous flow wherever possible. So we don't work in batches. We try to work in a single flow. Use supermarkets. So we'll see what the supermarkets are. Try to send the schedule to only one production process. Try to distribute the production to different products evenly over the time. So we'll see what the pacemaker is. Create an initial pull and then work on that and develop the ability to make every part every day. So that is some of the guidelines. So basically, this is just an example of how the value stream map looks like once you have gone through this exercise. So this is the material flow. These are the steps, every step, what is the step of your process. This is the data for every step like cycle time, changeover time. And then the top of the map is the information flow. So from production control, it goes like daily shipping, then they give the daily schedule to every step. Then who is the customer, how is this giving the demand, who is the supplier on this side, how are they giving the deliveries. And then at the bottom, like we saw that the timeline. So what is the cycle time for that step and what is the lead time for that step. So if you add that, then you get the total lead time, which will be a huge number, like 35 days in this case. And then the processing time is basically like in minutes, like 43 minutes. So if you take that ratio, it's a very small number, like maybe 1% ratio in this particular case. So then once we create this current state map, we then move to the future state map. So now we know, understand what are the bottlenecks, where is inventory, what are the issues we are having in every step of the process. We highlight those abnormalities or opportunities where we want to work. And then we put together a plan of reducing the inventory or reducing the defects, improving the cycle time, or any parameters which you think are important, and working on the bottlenecks. And then if you work on those things, then what will be my future look like? That we basically draw in the future state map. So basically there are 8 things we need to remember regarding the future state map. What is our takt time? Should the production build to the supermarket or directly to shipping? So whether it's a batch production or whether it's a continuous flow, we can define that. Where can continuous flow exist? So where will supermarket pull system need to be implemented? At what the single point in the process will the schedule be sent to? How will we level the production? What increment of work will be released and what process improvements will be necessary? So if we think about all these things, then we can put together a future state value stream map. So supermarkets, if you think like if you go to a D-Mart or if you go to a Reliance Mart, you have things in different compartments. There are limited things which are put there. But as you consume or as the customer gets those things, then they reach to a minimum value, and where it triggers a order or a reorder for that particular product. And then by the time that product comes, this product is finished. So that way it will replenish that particular product. So that way the customer doesn't face there is any shortages of the product, and also the supermarket is working at the minimum inventory levels. So that is the concept of supermarket. Then batch and queue versus the continuous flow. So batch and queue is like basically a very slow process. Continuous flow is definitely uninterrupted. So purpose of lean is to try and work the process as a single piece flow, but not everywhere it is possible to work as a single piece flow. So we can define the buffers in the process, but those are calculated, those are defined. And like I said, in the supermarket, there is a reorder point where, like, let's say if we decide a buffer of 10 parts, then if the parts come down to maybe 3, then there is a reorder point, and then the parts are produced to that, and that is called as the pull system. So basically now we are working based on the demand rather than we are working towards our production schedule. So it's not about just creating things. We can stop the production if the there is no demand, and if the buffer is full, so we can stop that process step and we can use that worker in some another activity. So this is basically how we do the level loading. So what I was talking about is like how many workers we have, what is the takt time, and then based on that takt time and then the process steps, how are we doing at every step, and which are the bottlenecks. And once we identify those bottlenecks, we try to work on them, and we try to reduce that particular step or work on that particular step to come down below the takt time. Then all this, if we level all these process steps, then basically we can achieve a single piece flow, and that will help us to move the product faster through the process.
3 minutes, please.
So at what single point we need to send the schedule? So basically that is called as the pacemaker process. So basically what is the pacemaker process? It's not exactly the bottleneck, but it's basically the slowest step in the process where it is working at the optimized speed of that particular step, but it is not able to meet the demand. So you focus your attention on that particular step, and then you try to improve the cycle time of that process by making some improvements, and then you try to bring that up to your takt time. And then if you work on that particular pacemaker or bottleneck, then that will automatically increase the productivity of the entire process. So what process improvements we need to make? So in order to attain the vision in the future state map, there will be many changes that will need to be made. So there are a lot of things like what we have identified as improvement opportunities. We work on all those opportunities. And as we are working on those opportunities, we can't work on every opportunity because there will be a whole list of improvement opportunities. So we need to prioritize the opportunities based on the bottlenecks, and we work on those first. So that way, that will give us the biggest impact for our productivity. And then we can work on the others later on. So, and biggest thing in lean manufacturing or using these tools is there is no or very less cost investment or capital investment. Most of these things we can work without any capital investment. So that is the biggest thing of using these tools is a lot of things we can just identify or understand the problem and fix it very quickly. So in summary, VSM is a tool to root out and eliminate waste in the process. It's basically used to shorten the lead times and balance the flow within the facility. It's maps without the execution and then we identify the muda or the waste and try to eliminate that. It's an iterative process, so it's not that we draw it once and it's done. So when we achieve our future state, then that becomes our current state, and we work again to achieve further improvements, and then we come with the next future state. So the cycle begins. So it's not, it's a dynamic document. So this is one of the example which actually I went through. So this is like last couple of slides. So basically VSM, this one I worked at Cummins in US. So that was, like I said, it was a very small plant. And then it was basically, we were getting electronic modules from the engines, which they use to store all the information of the diesel engine or petrol engine. And so that those electronic modules, when the engine failed or when maybe the engine failed due to some another reason, the whole engine used to come. And then when they disassembled the engine, the electronic module used to come to this particular plant for further investigation. And then we used to investigate that, identify if there is any fault in that. There were many modules which didn't have any issue. We could use them as reconditioned modules. And then there were some which had to be troubleshooted, had to be repaired. And then again, we used to sell them as a reconditioned module. So that was from the company itself. So it had a warranty and everything. So we used to get good price if we used to sell those repaired or reconditioned modules back into the market. So that was the overall process. And when I started to, like I said, I started working on the shop floor. So this initial testing step basically was the pacemaker. So where all the modules used to come and they used to get tested. So for if there was any fault or if there was no fault. So this was like the flow where no trouble found modules used to flow. So if they didn't have any fault, then it used to go for testing and then final testing, and then basically those were good to resell. But those ones which we found fault, then we had to use the CNC milling machine to cut them apart. And then we used to troubleshoot those. Then we used to repair those, and then we used to do the testing again. And then if everything was okay, we used to ship those. So in this process, basically, when I started looking at the inventory, so there was a huge inventory at this initial test process. So like almost 7.73 days of inventory. So it was, first thing is like not level loaded. So there is different lead times at different steps. You can see like 5.3 days inventory here.
Mr. Asimji, I'm sorry to stop you. Your time is already beyond 5 minutes, sir. Kindly try to
just
because there are two more
last 2
questions.
minutes.
No, next speaker is also waiting. He is also delayed. So kindly make it fast.
Yeah, just 2 minutes. So basically the lead time was 16 days, and then the cycle time you can see is like just 4,000 seconds or like in minutes. So where we worked on the inventory, we worked on buffers, we prepared a troubleshooting manual to quickly repair the modules. And then you can see in the future state, basically, the WIP went down from 1,000 or 1,200 pieces to like hardly 250 pieces, which we had defined buffers in different places. Lead time was reduced from like 16 days to 5 days. And then the productivity automatically increased from 65 pieces per day to 81 pieces per day. So if you work on the steps, if you work on the issues, what you find in the value stream map, then you can focus on those things, you can focus on the bottlenecks, and you get direct impact on your productivity. So basically that's how you can use this tool in the real industry. So I think with that, I will conclude my talk. If there are any questions, we can just have a couple of minutes for answering those.
Sir, your work is fantastic. And the way you explained is also very good. We are very happy. But only thing is, unfortunately, time is not sufficient and we made you to run through. So kindly excuse us having called you and, asking you to run. It is something embarrassing for us. But still now we are very happy with your explanation. Probably we'll be requesting you once again and, taking your all the knowledge to.
No problem. No problem. That's fine.
Thank you very much.
And if there are any questions, you can always email me or you can send the emails to me. I can reply through emails. So that's not a problem.
Thank you. Thank you.
As our Satyanarayana Garu said, it was really wonderful to learn. Even I am not a production engineering, but lot of things I've learned from your examples and earlier speaker also. So really it's wonderful. Hats off to you, and please keep in touch with us and do continuous patronage to our center and our institution of engineers. Thank you, Asim Inandaji.
Thank you. Thank you.
Now may I request Sri Hanumantrao Garu kindly, sir, kindly to address just only 2 lines I will read about you, sir. Sri Hanumantrao sir is a postgraduate MBA TQM with mechanical engineering background. He is working as additional general manager in Usha International Limited and responsible to establish and maintain quality system. He is a certified lead auditor for ISO 9001-215 and also IATF 16949-216, certified 5 years auditor by CII, Southern Region and faculty member for TQM Forum of CII. Is a 6 Sigma Green Belt holder and is instrumental for implementation of ISO 9215 at the Police Commissionerate of Cyberabad, Hyderabad, Warangal, including Telangana Special Police Battalions and support police station in Hyderabad, which is also trained a total of 10,000 plus employees of various organizations, including 10,000 employees of police establishments, TSRTC, and 5 years Kaizen and Quality Circle concept. Is a life member of Governing Council member and faculty member of Quality Circle Forum of India. Is a certified jury member to evaluate quality improvement projects and participate in state, national, and international conventions. And thank you, sir. Thank you. And I hand over to the engineer Hanumantrao sir. Sir, kindly to.
Thank you, sir. Thank you very much. Am I audible?
Yes, sir. Very much.
Yeah. I think if I would like to open my file, share my file now.
Yes, sir. And I think other now.
Share sound. Okay. Thank you. Am I audible, sir?
Yeah, very much audible, sir. Please go ahead.
Yeah. A very good evening to everyone. First of all, I'm thankful to Dr. Satyanarayana Garu, who has been the instrumental for giving me this opportunity in this. And I've been seeing from the 2:30 onwards, and the many speakers appraised him very well. And he has been what you call the zeal of this program to be conducted. He has been working since so many days, and this has been come true today. And I would like to wish all the dignitaries, and I can understand the time is very short, and I would also like to brief on the subject coming to the topic, today's topic, productivity improvement in SMEs with the lean approach. And we have seen the presentations by the most eminent professors, Dr. Rakesh L. Srivastavi and Mr. Asim Imamdar. And those two are really the eye-openers. And keeping that, and my topics will be today in the same lines, most likely the taking to the shop floor, the implementation part, and aiming at the SMEs particularly. So I would be covering quickly. I think I have 1 hour time or 45 minutes.
Only 30 minutes time, sir. Kindly.
Only 30 minutes. Okay,
Yes.
then I will quickly run through and then try to do this. And as Mr. Asim has rightly mentioned, if anyone would like to have the inputs, I can share through mail. Okay,
Yes,
the topics would be today, eliminate waste heating Muda. I think both the professors have covered this, and I would like to touch upon what exactly is this and how to address those Mudas, and with the support from the 5S concept as a way of life, and then supported by the other concepts, the lean concepts on Kaizen and Pokai. Okay, I will try to do it faster. Okay, the eliminate waste, it is a gateway for lean approach. So with the most prime requirement. And now coming to the SMEs, what to do, what they have to do. The question will be that, so what we have to do, we have to accept the problem. Don't close your eyes and ears. We all. So consider all of us from SMEs for the moment. And we have to plan a turnaround strategy like we have seen. And why we should do it? To survive. To survive this, we have to be understand the problem. And why we have to survive? And who should do it? And we have to only show it. Me. It should start from an individual. It should start from an individual and apply to the all team members. And who should do it is the me. And how should do it? With the aim in the mind, the profit. So any business, any organization, whether it is a manufacturing or a service, everyone aim at the profit. And the formula for profit is R minus C. It is revenue minus cost. So we should always attack the cost. So how the cost reduction is nothing but the waste reduction. So what is waste again? Unnecessary, unwanted and unutilized thing. If you see the productivity pyramid, aiming at the profit, who are all the functionary coming is the product value condition, quality, cost, delivery, and the production element, the 4 M's, man, machine, material, method is coming. And with the improvement of the 3 MEs, it is not only Muda, there are other 2 are also there that we will be seeing. And with the visual management. So we should be able to see everything, good and bad, and see the gap always and work towards that. And further, the prime thing will be the 5S. Today, I will be touching upon the basic concept. So any SME, without having a proper strong 5S in the company, it will be difficult for them to move on to implementing any concepts. So finally, if you see, the business excellence is possible through operational excellence. And again, operational excellence is the combination of process excellence and personal excellence. So personal is nothing but the people. So people are the main levers. And then the process excellence. Process is converting the input into the output. So with these two, we get the operational excellence. Through that, we get the business excellence. And if you see the performance parameters, which you all know, it starts from productivity and also considering the morale and environment. These are all the performance parameters for any organization. Then, all these things is the Japanese have brought out a concept called TQM, Total Quality Management. Under TQM quality management umbrella, there are so many concepts aiming for the lean approach. So what is TQM? It is an integrated organizational approach in delighting customers. Customers again 2 types, internal customer and external customer. Every process is a customer for the next. Every process is a supplier for the next operation. So like that, by meeting their expectations on a continuous basis through everyone involved with the team approach, with the organization working on continuous improvement in all products, all services, and all processes along with proper problem solving methodology. So this is the thing that TQM is called for and very prominently brought by the Japanese by taking every concept, taking the benefit from the every concept. And how this is possible, this we already seen by our previous two professors. What is non-value addition? So non-value addition activities our customer wants it and physically transform taking place. So what are the element of works? Value added, non-value added, waste or muda. Okay, this we have seen already. So as I told you, other than muda, there is two other wastes are there. That is muri, unreasonable burden on the people or machines. And mura is unlevel workloaded balance on the people or machines. So ergonomics, everything comes into picture. So other than muda, there are two other ways called muri and mura. Those things also we have to consider. So if you take every activity like Mr. Asim has very well explained, you have to bifurcate every activity while making the current state mapping. You will identify the red ones. Red one is the non-value addition. Those you can remove. So there is a quote from Henry Ford. If you always do what you are doing, always done, and you will always get what you are always got. So that means what it shows is you should always keep thinking for doing better tomorrow. So what are all the forms of waste? So there is one saying by Shigo Shingo, the Japanese author. He says the most dangerous kind of waste is the waste we don't recognize. So this is very difficult. Identifying problem is another thing is. So focus on constant elimination of muda. This should be there. And Taichi Ono, the founder of Toyota, what he said is there will be people waste, quantity waste, and quality waste. So there will be three types of waste will be there. And as our previous professors have already told, it is the downtime which we look at it. In the earlier years, it was the 7 ways. And to remember, the word given is the TIM word: transport, inventory, motion, waiting, overproduction, overprocessing, and defect. Later stage, people realized and added one more is the non-utilized talent. That is the, and to remember with that addition, the downtime word has come. And just before we have seen from the Asim, he has added one more waste as a safety, under safety. So now the latest focus will be attacking all the 8 or 9 ways. So reduce the downtime. So what one by we will see. The first one is the downtime. The word is D, defects. Of course, defects you have to eliminate. If you don't eliminate, this will be the situation like you are seeing in the picture. The rejects will be more than the good parts, and there will be rework. Then second is the overproduction, more than required, leading to so many inventory and loss. Then overproduction causes by large batch size, unreliable processes, unstable schedule, unbalanced cells or departments, working to forecast, inaccurate information, not actual. So it has got so many factors for overproduction. And then next is the waiting. The waiting is for instructions, waiting for material, waiting for supplies. I mean, it can be anything. So waiting causes so many: lack of adequate maintenance, need of proper tool, lightly set up times, lack of cross training. So all these will be there. Then next is the waste is the unutilized talent. So we have to identify people, always try to recognize them in which area they are talented, and we have to try and use them for the skilled work. As rightly mentioned in the first lecture, to implement the Six Sigma, we have to have a skilled people. Like that, we should not lose the people who are talenting. So how this non-utilized people is coming as, everyone that comes to work has creativity. Everyone at work comes up with the improvement idea. So however, we never take the time to ask people, how can we make the job easier? How can you job better? And how can you make it faster? When you start doing that, you will get the answers from them. Like that, you can also give them some assignments and find out the talents from them. The next waste is the transportation. Of course, we all know the unnecessary transportation will lead to the internal or external, another waste. And then the inventory, of course, everyone knows. So this is a very good example. If you can see carefully, there are two pictures, left side and right side. The theme of this is, if we have high level inventory level as shown in the picture, we all will be not knowing the actual issues. So when inventory level reduces, the problems are exposed. Otherwise, all the years without addressing the inventory, we will be living with the problems, and that was indirectly or directly damaging the organization and taking to the losses. So inventory is the very dangerous one. And next is the motion. Motion is within the organization, the ease of work, and it is not transportation, it is motion only. The waste of motion is any motion of a man, equipment that does not add value to the product or service. So you can see some example here. The left side is not following the actual motion. The right side is organized way of doing. And here also zigzagging. So a lot of waste of time, money, energy, everything. So now next is the extra steps, means over processing. So we want to make what the customer wants, and what the customer wants is exactly what they want. So in the quantities that they want and at the time they want. So that means we should avoid whatever is the extra steps taking, we have to remove that. If you say, for say, an example, over processing is putting more into the product than the valued by the customer. Painting of unseen areas. If you take a vehicle where the unseen area, unaffected area, if you do painting, that is a waste process. Like that, you can get so many examples. And to basic for any SME to implement and improve the business, the foremost thing is the 5S. Of course, everyone knows 5S, and it is not a big thing, and it has no science, technology, no mathematics, statistics, nothing. But with the real conscious and with the everyone involvement, if the 5S should be a continuously maintained. It is a simple down to earth concept. And now we have to eliminate the 8 ways. We have to first organize, manage our workplace as a first step. That is why I brought this 5S into picture. And 5S, it is a way of life for every. And 5S is not limited to the work area. It is for the whole life, home, society, everywhere. The 5S we are seeing. It is a workplace management, the first step for improvement for any organization. And it makes us to improve our workplace, to work comfortably, to live happily, and to visit repeatedly. So if we maintain our organization or our office or our home, people would like to visit us. So here in the business scenario, the customers, we have to attract customers. Whenever they come, our workplace should be first. The workplace speaks about our way of working. And where 5S can be applied, there is no place in the world where 5S cannot be applied. It can anywhere apply. So if you see that in a nutshell, what is 5S? It is 5 steps. First, starting out, set in order, shine, standardize, and sustain. And 5S workplace, one concept behind we have to see is an improvement management tool. If implemented properly, it ensures continuous improvement culture in the organization. The misconception of 5S is for improving housekeeping. People think, even still today, some people think that 5S is housekeeping. No, it is only a byproduct. It is actually the main purpose of 5S is to discipline ourselves, conduct daily audits, find non-conformities, abnormalities, and take corrective and preventive action so that the shop will be or the house will be in a good order, good manner always. And if you take it in a 5S in a behavioral part, the 1S says, say what you do. Second is, do what you say. So it should be factual approach. This speaks about the factual approach. And third is the show improvements from learning and corrections. Fourth is show evidence of what you say and do standardize. So whenever it is comfortable, whenever it is giving you good results, then standardize. The fifth is the stick to the rule, sustain, audit. Audit is not a big thing. Verify whether I am doing correctly or not, whether that my team is whatever we planned, whatever we have systemized is following or not. That's all simple way. And if you see the work life, we spend in this area, if you see 35-40% of the time is going to the workplace. So like that, we have to make people aware, mainly the people who are working. When you say, people start thinking, yes, I am spending more time at the workplace. I must do this. I must involve in this. I must contribute for the organization. Like that, we have to bring the people aware on this. So what is our workplace? Where one works, where there is an output, where there is a creative activity, and where value is added. So why 5S? It reveals the abnormalities in workplace. So if you see, there are so many abnormalities. So like this, you can identify, distinguish. So most dangerous ways. Then focusing attention on the abnormalities. So certainly it reduces the abnormalities when you consciously start verifying. So ask whether we are doing enough, improving our workplace. Like that, we should start. And the 5S founder is a very young gentleman, Takashi Wasada. He's the author of the 5S concept. What he says is we can always find lots of room for improvement. Only thing is we have to look at it, whether I'm doing correctly or not, whether my place is intact or not. So like that, if you see everybody in the area, then we will definitely bring out the improvement. So we should not remain into the routine activities. That is what he's saying. And it also works as a error prevention. So prevention is better than cure always. So there are so many examples which we must have seen in our experience, how the 5S difference will come. And not having 5S, the relationships are also not maintained. They avoid people. So see bad environment. This is how it will be. And it decreases so many things: injuries, production costs, downtime, defects, supply mistakes. And it increases safety, morale, product quality, experiment life. So many benefits are there. So now you see the 5S, there are 5 steps. I think everyone knows this. And it gives the safety first, and it also takes us towards the waste elimination. So it will be high impact and the low cost, and we make money actually by selling the unwanted things when we start doing 5S. So adherence to standards is the key. And if you can't do 5S, you cannot do lean. So for bringing out the lean approach in any organization, the foremost concept is the 5S. In the 5S, the first thing is SIRI, that is reorganize the thing. See, if this example you will be seeing throughout this 5S. This is the shell, how it is, you just see. Then when we do our journey, continue our journey in the 2nd S, 3rd S, 4S and 5S, we will be bring out the improvement. So to remove unnecessary item from the workplace that no longer valid, and you eliminate all the things, and like this, whatever is the thing, many stationary things, and we have to question, do we really need this? Then why you should start? We should start for the betterments. There are 3 steps again. There are 3 steps. One is the evaluate and photograph. So whatever you are, before implementing 5S, first we have to evaluate, take the photograph as is, where is basis. Then identify and red tag it. Whatever is abnormal, whatever is you feel not required, you red tag it and then decide. So there will be some wanted, not wanted and doubtful. So the doubtful you have to send it to the red tag area where there will be a separate place, and keep the only whatever is required, and the third is the whatever is not required, send it. The first example, if you see, after doing the SIRI, the right side picture is some look is changing now. It is taking its shape now. So what is red tagging? Red tagging is a card where all the information is given on the item according to our own work area. The tag can be in any size, and people will be enjoying in doing this. And there are 7 steps for red tagging. Identify the target area, define the criteria for red tagging. And again, criteria is usefulness of the item, frequency of the item, and quantity of the item needed. Based on that, then design and make a red tag. Red tag need not be a same size. According to the item that we use, we can optimize that and start red tagging. And then the team effort is required here, and have a log of that, and then evaluate red tagged item and dispose obviously whatever is not required. Then 7th is the move to the holding area. This holding area is the one in the organization. The whatever doubtful or unwanted will come here, and we should have a review frequently and then dispose it or reuse or use it somewhere else. Then what to do? We have to remove all unwanted things. And one more thing, if you see one example, be careful when you are discarding the items. Here, one example is the boss is asking for some file to his subordinate. There is some urgent customer inquiry has come, where is the defect file? So these people, out of the excitement, they have thrown everything. So that should not be the thing. So like that, we have to take care and do this. And then you can see the sort example. Then the next step is the set in order. Why straightening? To arrange all necessary items. See, the left side example is a cowboy example. He should be ready to fire whenever there is a thief or somebody. So our preparation, everyday day-to-day work will be like that. That example makes us alert, makes us faster in doing the works. So we have to find a right place. And what is the right place for this? Then we have to keep it straightened and see how this nicely arranged. It is easy to go and purchase any fruit. So many are arranged, nicely organized. This is how the cite an example. And it removes the frustrated of searching. When you do the second S, cite on, we will come out of the frustration of searching. It also reduce the cost because we will not lose anything. And cite on systematic arrangement straightening the quality, ergonomics, safety, morale, visual workplace, standard work, productivity, inventory control. There are so many things. And again, there are 3 steps: understand the current situation, decide where things belong, and decide how things should be stored. So this is how we can see the example. A place for everything, everything in the same place, clear boundaries. Then point of use. According to the point of use, we have to decide the items, materials, tools, furniture, whatever it is, and arrange. Decide how things should be stored. Then ease of finding. Now, right side picture, if you see, it is very easy of searching. You can prepare the shadow boards and maintain so many things. You can eliminate the searching time. So there are 3 F standards are there. One is the fixed location, fixed item, and fixed quantity. Keeping this in the mind, we can organize the second S, point of use. See, this man is struggling for doing the work. He has, within the given space, what he has done is, he has changed the table like this. So without bending, he has to work for so many hours. Every time he has to bend front, and we'll be having a ergonomic problem. So a simple technique of just making a slanted table is helped him. So like that, we can have the techniques. There are no rules for 5S. All rules are made by us. It is only a common sense. So you can have the fixed location, fixed item, fixed quantity, and then you can handle so many things. Now our first example has taken some shape. See the difference after second is. Now third is the sideshow, keeping the sweeping. So it is not, as we have seen in the beginning, it is not the housekeeping. It is straightening the, disciplining us. So to clean in such a way as to identify and remove sources of contamination. So in the third is, what we do is we unknowingly will be doing the inspection. So cleaning means inspection. Why to sweep? It improves the morale. It improves the safety. It prevents the breakdowns. And how to sweep? Clean with meaning. And restore goods condition, find the sources of filth, eliminate root cause, reduce the need to clean. So specific steps to thing is, own your zone, have a zone, parallelly implement this so that simultaneously entire organization will be taken care, set standards to sweep, what to sweep, who to sweep, and make a 3W1H approach and keep the clock time and start at the same time. Have that, you have to develop those things of disciplines. Clean it while still small. Don't wait for that. So then clean it clean, a visual thing. And finally, if you see, the third is, the essence of third is we are only basically keeping the things clean, and plus we are doing the inspection, and collectively what it is giving us is, it is developing a caring attitude. All of us, by implementing, and every person will develop a caring attitude. Again at home also, when we have a discipline of doing at a frequency, every appliance at home, we develop a caring attitude of everything. So we can reduce and eliminate the breakdowns. We can bring out so many visual controls, visual, easy to identify. We can distinguish them. Then observe the tools carefully. If you see, if you organize things like this, if any tool missing, you will not come to know. Something is missing. This picture you cannot know. When you put it in a boxes and right there, whenever any missing is there, you can identify. See here, vice is missing. How you are able to identify? Because you have put it in, organized it in a proper way. So like that, this the third S will be useful. So many examples are there. The filing system you can do like this. The laboratory equipment you can organize like this. The office furniture you can organize like this. Within few seconds we can get it. Then standardization and visual management. The fourth S is, the main activity will be in the only first 3 years only. The other two, fourth S and fifth S, are only the monitoring activities. Here the standardization and visual management. One example, traffic lights. So again, Taichi Ono, what he said is, where there is no standard, there can be no improvement. So we should have a standard way of doing, standard way of understanding. Okay, then we have to prepare some SOPs according to the thing, and we should prepare in such a way, standard operating procedure, why, the purpose, what we have to do, who will do this, who will be accountable to what, when to use the reduce, and where the place indicator, and how many the amount indicator. Like that, we have to do SOPs. And like this, we can do the implement standards. And after implementing, standardizing, it is only a 5 minutes, 5S, manufacturing side and administration side. We can have a list of activities, involve everybody, make everybody accountable, then things will be all right. We people, normally industries, what we miss is we don't do the audit and we don't do the accountability of the person. Then that is why this 5S is going back. See, the simple table can organize like this with a standardized way. And 5, we can use the color codes as per the systematic way and according to our usage. See, use 5S to improve workplace efficiently, organization and cleanness through visual communication. We must try to give do's, don'ts and simple visual communication so that people will follow very easily. So rectangle area we can keep like this, floor marking, then identify everything, red color code, material flow arrows you can give, and position marks, shadow boards for any type of item, standardized filing. Then for the fire, we see a lot of simple symbols to understand. Then safety, mind the gap. Our first example, after doing the standardization, see, this has taken a good shape. In what shelf, what item is coming and how it is nicely organized. Compare the first one to the left side to the right side, then you will understand. See, if you see here, what it is, there are so many lights and so many fans. Under 5S implementation, what we have done is we identified on the numbers and the same numbers are put on the switches. So there are 3 benefits actually. For operating any single light or single fan, within no second, within short time we can operate. Second is easy to operate. Third is people will love to operate. And third is you will be saving the wear and tear of the electrical items. That is how the line of fire behind the door you can keep like this. It will allow, it will not cause for the save. And standardized way of working, identify everything. Don't depend on the people, only depend on the systems only. The waste collection trolley, you can make trolley like this, identify everything. It's only one-time job, and then it is easy to dispose on a frequency what we fix. So standardized policies, we can make the standardized policies and standardized procedures and standardized practices. Everything you have to standardize, and that will be the thing. Then 5th one is the Shitsuke. It is self-discipline. So after completing all 4 stages, sorting out, eliminating everything, then after systematic arrangement and after doing the developing a caring attitude of every item, and after standardizing, making the rules, then the 5th is only to sustain. It is only a sustain. So Hitsuke is sustain is everyone stick to the rule and makes it a habit. It is only a habit formation. And how it is possible? We have to have a 5S committee. We have to have a 5S training on the people, awareness of the people, and you celebrate 5S month, display the posters. And foremost, very important thing is you should have a PDCA approach. And second thing, you should have a audit, make a practice every day and have a pledge on 5S. Some organization, they do a pledge. So that make people aware that we are doing 5S. Then safety also, we can have a safety evaluation. So to sustain this 5S, we have to do a simple audit and use the radar graph in every stage that visualize the thing where we are for every stage. See, these are some examples 5S implemented in the police stations. So they are also come out with good ideas. They are filing arrangement, and even they have gone to the area where they have put a board, am I punctual? So this is making them punctual. And see, even if it is irrespective of any big shed or anything, big shop floor or whatever it is, with 5S, it looks very nicely. Nice. And we can have a best practices. We can list down at home or at maintenance. And this is about the 5S. The organization structure should be, one top management drive should be there, and there should be a steering committee. And for the steering committee, you should have a coordinator. If it is a MNC type, you should have a corporate coordinator, and every unit you should have a level coordinator, then zonal head, then zonal coordinator, and then zonal leader, sub-leader, And this leadership is a rotation based you have to do. So that you have to make involve everybody, then all employees. So this structure will make the organization to put into the in continuous implementation. So this zone wise register we can have, then 5S audit structure. The audit will be initially should be self audit, then CFT audit, transfunction audit. Among the zones we can conduct the audit, and then we can have management audit once in a while. So the simple, the S-wise, you can use have some specific marks and evaluate them, and you can see the score, put in the radar graph, and then you will be knowing about the 5S. So now I will take you to the another one. So this in the lean approach, now we have seen quickly about how the 5 steps of 5S, the workplace management has to be organized. Now, the another concept which we have seen in the previous presentations also is about the Kaizen. So what is Kaizen? The Kaizen is to make our life easy. So make our things easy. So we will see what is Kaizen. So achieving excellence is a never-ending pursuit. So simply, if you see the attitude towards quality, if you see Dr. Philip Grasby, he says,
slide is not changing.
So any organization will start with the uncertainty to certainty.
Slide is not appearing.
Slide is not appearing.
Slide did not move, kindly.
Slide is not appearing.
Slide is appearing but not moving.
You know, no slide is coming. It's only 5S. Still is only 5S. It is there.
Okay, okay.
No, that is, I think, last it has come to format like that is 284 slide.
Not Kaizen. Kaizen you have to go.
Yes, yes. Now is it appearing?
Be fast, only 5 minutes.
Okay, sir, we'll complete. Now is it appearing, Kaizen?
Yeah, not, yeah.
Okay, I'll quickly complete this. I'll go to direct to Kaizen only. We'll go to Kaizen. So Kaizen is, it is a continuous improvement. Kai, change for good, change for better, the Jan. So the philosophy assumes, according to Masaki Imai, our way of life, be it our work life or social life. So Kaizen way. So Kaizen idea was derived from Buddhist philosophy. Kai, change for better. So change for better. Kaizen means change for better. So he is the person, he has brought this. And Kaizen philosophy is that, so it requires sophisticated problem solving expertise as well as a professional and engineering knowledge, and involves people from the different working together. So it is Kaizen is everybody's job. So there are 3 pillars for Kaizen: housekeeping, waste elimination, standardization. I think we have covered all these 3. And housekeeping, we have to have a 30-second storage and retrieval. So as minimum as possible, every work area we should have that. And of course, this you have seen, the housekeeping we have to maintain in that way. And Muda in manufacturing, Muda in office, that we have to see. And of course, standardization we have seen already. And after that, the Kaizen and TQM, total quality management, it emphasizes the continuous improvement of the process, involves all functional units, motivate and involve employees, satisfy the internal and external customers. And there are totally, there will be 3 levels of people will be there. The level when people deny what are problems, that are problems are, don't want to see them. They don't want to see the problem. Second level is people admit that there are problems, but find excuses not being able to solve them. The third level is people accept the first fact that there are problems but unable to solve them because they don't know how to attack it. This is some preparedness towards the solving. Level 4 is people want to see potential problems. For this, try to visualize them. They will attack them by learning proper methods. The fifth level is people know their problem, methods to solve them, and how to involve all the people to attack them. So they are ready to attack any problem and to change their organization if needed after solving the problem. So it is the management's main target to move organization status on level 4 and level 5 so that the implementation of Kaizen, any other is very possible. So there will be so many things, muri, we can take it, and this will make sense. So if you see one comparison and close it, so that you will understand the easiness of the Kaizen. If you compare Kaizen with the innovation, it is a small step, innovation is a big step. It is a conventional know-how, innovation is a technological breakthrough. Kaizen seek only efforts, innovation, investment. Kaizen is a process-oriented, innovation is a result-oriented. It is an easy, adaptable concept. Innovation is a creativity. It is a teamwork system approach. Here it is individualism. And it is people-oriented. It is a technology-oriented. Here information is open, shared, information closed. So like this, when you know the difference, it is easy to implement about the Kaizen. Then cultural differences between traditional and Kaizen. This also makes us makes us to have insight look. See, management culture in the Kaizen will be preventive. Traditional company will be crisis. View of customer is always market in, here product out. Somehow you push the product to the customer. And if you see the view of people, they are assets, but traditional it is cost, adding cost. Shop floor methods are consistent improvement, every continuous improvement. Here traditionally static and routine. And item measurements concern trends are improvement you can see, but here whatever result comes only, we will be living with that for the traditional company. And support staff is always serving the shop floor, and here critical to shop floor. They become the critical. And information is shared open, here it is restricted and closed. And appraisal unions is partners, they are adversary. Development is ongoing always, and traditionally is do as I told, don't use your brain like that. Supervision is despecialized, here it is specialized. So management concern is CFT support, here it is a functional control. I think this is the right approach, least effort, normal effort, and maximum effort. So it is eliminate the obvious deficiencies. I think I have very limited time. This is the one Kaizen format where everything is coming here. If you just see for 1 minute, you will understand. Then we'll close it. How to bring out the Kaizen? Left side, there are about totally 4 steps are there. One is the Kaizen theme. What it is? The present status. Then you have to do a simple why. If you ask questions, you will get the idea, the root cause. When you know the root cause, you get the idea and then implement it. And put the photograph of before situation and after situation. Then you write what is the start date, end date, and put the photographs of the operator level so that it gives the motivation. I think with this, I will close my presentation. There are so many examples which I wanted to know. So thank you very much for the patience listening. And any questions, you are welcome.
Thank you, sir, for your wonderful and practical. Really, it is, I think, worth not only manufacturing, and it is worth in every office and
sorry,
every
sir.
place.
Sorry, sir. It's not audible properly. Your voice.
Are you able to hear me, sir?
Right, sir. Now it is.
Yeah. Sir, it's really a wonderful, this thing is not only applicable to manufacturing industry. In fact, the way you presented is really worth, even it is a house wife also who does in the home also. This is applicable each and every place. That's what, in fact, after going through your excellent presentation, with so many examples and this one, and here actually we are unlucky because of shortage of time. We have to rush to, we have some other meeting. Really, sir, we miss you, and I hope that we continue this your patronage, and also we'll come up with some other good program again in the near future, sir.
Sure, sir.
And,
Definitely.
I also thank our Dr. Satyanarayana Garu for really arranging such a beautiful topic, and not only topic, it is, I think, applicable to, as you said, the lifestyle of each person, whether it
Yes,
is the health part or your behavior or your lifestyle, whatever it is really is worth finding all these things. Thank you very much, sir. And
Thank you, sir.
of course, we are running short of time. Summarize, I'm not doing. Whether Satyanarayana
Okay,
Garu, sir, would you like to summarize anything? 5 minutes?
You ask Saraswathamma to propose vote of thanks because always.
Okay, okay, sir. Okay, okay. I request now, Madam Professor K. Saraswathamma, committee member of Telangana State Center. Kindly, Madam, you can summarize and then propose vote of thanks.
Sir, good evening. Good evening, one and all. So it is a privilege to give a vote of thanks on behalf of the IEI, Telangana State Council Center. Respected Chief Guest, Dr. Jaitit R. Joshi, Program Leader, Pusha, DRDO, Hyderabad. Engineer V.B. Singh, FIE Vice President, IEI. Dr. S. Satyanarayana, FIE Chairman, Production Engineering Division, Board, IEI. And Dr. G. Ranganath, FIE Chairman, Committee for Advancement of Technology and Engineering, IEI. Engineer B. Brahma Reddy, FIE Chairman, IEI in Telangana State Center. Today's webinar moderator, Dr. G. Chandramohan Reddy, FIE, former Honorable Secretary, IEI, Telangana State Center. Principal, MGIT, and Professor, Department of Mechanical Engineering, CBIT, Hyderabad. Speakers today, Dr. Rakesh L. Srivastava, FIE Council Member, IEI. Engineer Asim Inamda, IVEX Lifestyle Vertical Expert, Indorama Ventures Limited, India. Engineer Hanumanth Rao, Additional General Manager, Usha International Limited. Past Presidents, Vice President, Council Members of IEI, past Chairman, past Honorable Secretaries, members of Telangana State Center Committee, IEI, corporate members of IEI, distinguished guests, representatives of media, ladies and gentlemen. On behalf of the Telangana State Center of IEI and on my own behalf, I convey our sincere and profound thanks to the Dr. Jaitit R. Joshi, Program Leader, Pusha, DRDO, Hyderabad, address the gathering as a chief guest. Also thank to Dr. Chandramohan Reddy, FIE, former Honorable Secretary, IIA Telangana State Center, Principal MGIT and Professor, Department of Mechanical Engineering, CBIT, Hyderabad, for moderating the webinar. I would like to express my gratitude to the speakers, Dr. Rakesh L. Srivastava, FIE Council Member, III, Engineer Asim Inamda, IVEX Lifestyle Vertical Expert, Indorama Ventures Limited, India, Engineer Hanumanth Rao, Additional General Manager, Usha International Limited, delivered the technical talks. I'm also thank the dignitaries, past presidents, past president, council member of IEI, past chairman, past honorable secretaries, members of Telangana State Center Committee, IEI, corporate members of IEI, and others who made it convenient to attend this event. I also thank the representatives of media. Thanks, and so I'll conclude it. So all are requested to raise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Seventy, 40.